Bellman, the Scientific and Statistical Committee staff officer with the council. The other staff officers are actually taking the lead on this one in particular, but I'm just here to listen in and make sure I understand the content of the general discussion today and can help answer any questions about feedback on how the post-reporting from this ties into the full SSC and where we go from there. Thanks a lot.
Thanks. And yeah, Angela, hopefully you can swing by an SSC meeting soon, like maybe in November, and we can all meet you in person. Marlene will tell you that we're only sometimes scary. And as far as logistics, we do have an SSC and an STT discussion lead on each of the items. So I'm going to kind of leave it up to them whether they want to take questions from non SSC and STT members during the presentations. There is a public comment period before and after the main meat of the meeting, which is discussing the derivation of the proxy SMSY MSP ratio and FMSY value suitable for use in Sacramento River Fall Chinook from Will Satterthwaite, and then the Sacramento Fall Chinook cohort reconstruction in comparison to the Sacramento Index from Dr. Emily Chen in the afternoon. And then we'll have a little just logistics wrap up about reports following that second public comment period. Are there any concerns about the agenda, additions, subtractions, concerns about timing, or should we go ahead and approve that? I'm looking for hands and I don't see any. Mike, are you okay with approving the agenda?
Yes, the agenda looks good to me. Thanks.
All right, then I'm going to turn it over to Mike for public comments.
Thanks, Galen. As Galen just mentioned, there are two public comment opportunities at this meeting. The first one is going to happen here in a second, and at 2:45 p.m. or following the agenda item C1, there'll be a second public comment period. So at this point, I will open it up to public comment. If you could, please raise your hand. And if that's not working, that feature is not working for you, feel free to speak up. I do see a hand here, Brian McLaughlin. Please go ahead.
Can you hear me all right?
Yes, I can hear you fine.
Great. Thank you all for the opportunity to provide public comments here. And I want to also first thank the Sacramento River Fall Chinook work group. I've attended a number of their meetings and read their reports. They're very informative, and I particularly appreciate the thoroughness of the May 2024 report. It's a lot to digest, especially for a layperson like myself, but the information is very important in trying to understand the challenges that are presented, both scientific and policy, from developing these new conservation and management measures for this stock. I want to just touch on two issues that are concerns to me that raise questions if you're proceeding in the right direction here. The first concern is whether it's scientifically sound to use Klamath River Fall Chinook and Rogue Fall Chinook spawner recruit dynamics and the MSY calculations as a proxy for Sacramento River Fall Chinook and the spawner recruit relationships there to derive FMSY and SMSY. There's a lot of differences, at least that I perceive, between Klamath Fall Chinook and Rogue Fall Chinook and Sacramento River Fall Chinook on the other hand. Especially with the Rogue stock, there is very little to no hatchery origin natural component to the natural area spawners there. And so I would expect the population dynamics there to be significantly different than in the Sacramento, where the majority of natural area spawners are of hatchery origin. I also understand there's a significantly less PHOS in the Klamath fall Chinook stock than in the Sacramento fall Chinook stock. And I believe the MSY calculation there for yield of natural origin fish is there for natural origin fish there. And I question if that's appropriate for the Sacramento River fall Chinook stock because of the significant amount of hatchery fish in the natural area population there. There's a lot of habitat differences. It's been noted that the Sacramento is probably more degraded habitat and probably less productive. Very different watershed characteristics in terms of gradient. Much larger, I think, tidewater estuary bay habitat in the Sacramento than the other two areas. They're in different ESUs. And I just question whether it's the Klamath and the Rogue are good representations that should be used as a proxy. My second concern is even more fundamental, and it is whether it is scientifically sound to use the Ricker model, or for that matter, even a Beverton Holt model as proposed, where the population dynamics of Sacramento River fall Chinook appear to be so influenced by hatchery spawners in natural areas. The work group's May 2024 report really articulates this concern better than I can. And I just want to highlight a couple passages because I think they encapsulate my concerns. And on page 7, it says, in discussing the theoretical derivation of the models typically used to estimate SMSY for council managed fisheries, the work group noted challenges in interpreting and applying the models to a stock that consists of a mix of natural and hatchery origin individuals, and where a large number of hatchery origin fish spawn in natural areas. And there's Appendix A that really discusses this. I'm sure you've all looked at that, but it does note that there's some logical challenges given the situation, and I won't articulate it more because I know you're probably going to address that, but it's a real concern to me conceptually whether the approach that is proposed here is even conceptually one that should be applied given the large amount of hatchery fish in natural areas in the Sacramento, and maybe a different path forward is the one that should be taken. I do think that the Magnuson-Stevens Act allows for some flexibility and for some different approaches, and I would encourage you to maybe explore some different approaches that might better be used for conservation and management measures and to determine an MSY point. And in doing so, I heard a number of people introduced at the beginning of the meeting that are likely familiar with the situation in Puget Sound. I know that's an ESA listed fall Chinook ESU up there, but it seems like there's some analogies that may be applicable to Sacramento River fall Chinook in that the habitat in some South Puget Sound watersheds like the Green and Puyallup are likely degraded to the point that they will not support natural area populations of natural origin Chinook without a continued augmentation of hatchery fish on the spawning grounds. And that is something that may be the case also in the Sacramento watershed, or at least significant portions of it. And so there may be some ideas of how to approach this issue that can be applied, that were applied in the Puget Sound Harvest Management Plan up there that may be applicable down here. Anyway, those are my two big concerns. I do appreciate the opportunity to comment, and I look forward to hearing your discussions about these issues. Thank you.
Thank you for the comment. Any other public comments? I see no new hands coming up. Last call for public comment here. All right, seeing none, I think we can close public comment, at least the first public comment period, and move on with the agenda.
Yeah, so I am ready to rapporteur this section for the SSC. I will leave it to Mike and Owen to go ahead and frame the question and set things up for Will.
All right, this is Owen. So the first topic we have here is to look at potential use of proxy SMSY, SMSP ratio, and FMSY values for use in the Sacramento. We have a document detailing this with several appendices. The first of which conveniently shows that the two values we're looking at are equivalent, making this a little simpler. I believe we also have a presentation that Will be providing for us. Our rapporteur is ready to go. I will just ask Will if he prefers to get questions during the presentation or wait till the end.
Yeah, thanks, Owen. I think clarifying questions as we go are welcome. I'm not sure how effectively I'll be able to see hands. So yeah, if you or somebody can interrupt me as needed. In some cases, I may want to defer questions to a later slide that I think may answer them. And like, I think the broader discussion probably should wait for the end, but yeah, happy to take questions as we go.
Okay, great. And then I'll hand it over for Mike for any other comments or questions before we get started.
Thanks, Owen. I don't have any particular comments or questions at this time. I think, you know, the STT and the SSC subcommittee have been through this process for a while. So looking forward to hearing this presentation from Will.
Great, thanks, Mike. Can everyone see my slide okay?
Yep, looks good.
All right. And so, yeah, this is, the slides have been, it's posted to the SSC's Google Drive. I sent it to Mike last night. I believe he sent it to the STT members. If other members or if members of the public want a copy, shoot me an email at the break. But so, yeah, so first I thought I'd start out by talking about how we got here. And actually Brian's public comment set some of this up. So yeah, we do face this sort of logical challenge in, can we estimate MSY-based reference points directly from a spawner-recruit relationship fit to Sacramento River Fall Chinook data? And the presence of a large number of hatchery origin fish in natural spawning areas makes it difficult, or one might even say impossible, to do that in a sort of logically consistent framework. And so, but what we can do is fit a relationship between, say, natural area spawners and some estimate of natural origin production. And so one potential, way of coping with a situation would be, well, if we can identify the spawning escapement that maximizes production, and we can somehow come up with, in those systems where we can estimate MSY in a more logically defensible way, is there sort of a typical ratio between the escapement that maximizes production versus the escapement corresponding to maximum sustainable yield? Could we just apply that same ratio to an estimate of maximum production that would be informed by Sacramento Fall Chinook data? So that was, something the work group floated as a possibility. The STT was supportive of. Meanwhile, the SSC recommended that the currently used proxy value for FMSY, so that's the fishing mortality rate, should be updated using recent data from other Chinook stocks that are representative of Sacramento Fall Chinook under current conditions. And so, right away it was obvious that these were, somewhat related suggestions that could probably be informed by a single literature review. But upon, sort of further consideration, at least if you make the assumption that you can describe salmon population dynamics with a Ricker spawner recruit relationship, then mathematically these two things are one and the same thing. I don't think that's some big fundamental biological truth. It doesn't work for, say, a Beverton Holt or some other spawner recruit relationship for salmon. It also doesn't work for Iteropara species like groundfish. I don't think we need to go through all the math, but so on the left was just my first attempt at proving to myself that these things were the same. I was talking to some stock assessors who work more on groundfish at the Southwest Center, and they filled out that whole whiteboard on the right, seeing under what conditions is this true or approximately true for groundfish. Basically, it's just not true for groundfish. So what is the basis of our current FMSY proxy? So it comes from this document, an appendix to the 2011 analysis that I believe sort of accompanied establishment of reference points for salmon in general. And so the whole documentation of the proxy is basically this table here, and then about a page of text. And if you just look at this table and just look at the page of text, you would get the impression that what they did was looked at individual studies, pulled out individual values of this alpha or productivity parameter, calculated FMSY from that alpha value, and then took the mean across those 20 stocks of the FMSY estimates they got. So there's no mention in that report itself of dealing with covariates. There's no mention in that report itself of this adjustment some people do to alpha called alpha prime that's meant to sort of account for what they call process error and account for sort of differences between the mean and the median of a log normal distribution. Some of you may remember a similar discussion from 1 or 2 years ago about the SI forecast. And if you go back to the individual studies that are cited here, you can sort of figure out what the individual studies did with respect to those kinds of questions. Unfortunately, what you can't really figure out is what was the reasoning employed when deciding, should we use alpha versus alpha prime? There were some studies that only reported alpha, therefore alpha was used. Some reported both alpha and alpha prime. In some cases, alpha prime then was used. Some studies reported alpha and all the information needed to calculate alpha prime, but alpha was actually used. So, I know that the council really appreciates short, concise documents, but there's also, at least in my mind, a cost of making things a little too short, because if we disagree with some of the choices that were made, we don't really know why those choices were made initially. But so that's the basis of the current proxy. Just one other thing to point out. So here's the brood years for the different studies. Note you see a whole lot of numbers that start with 19. You see a single number that starts with 20, and then it has a 0, 0 after that. So not a lot of very current data going into this. And so the first thing we did was look for, are there either analyses of other stocks that weren't considered in the original proxy, or are there updated analyses for any of these existing stocks that might be useful to inform an updated proxy? And so for the reasons we already discussed, we really can't estimate MSY for Central Valley fall run. We talked a little bit about, could we use a winter run cohort reconstruction to reconstruct natural origin recruits of that population? But winter run are very different from fall run in their biology. We're talking about an endangered stock that, at least during the study period, was limited to one very small stretch of river, very different age structure, very different timing of life history events. And there is also still some hatchery influence in natural areas for winter run, although much less. And the brood years there, 2002 to 2015, that's kind of right on the edge of what you'd want to try to fit a spawner recruit curve. So for all those reasons, we didn't think that winter run Chinook were a good stock to be informing the proxy for Sacramento fall. For centralized spring run, again, there are a lot of life history differences. There is this cohort reconstruction based on tagged wild fish, but since it was only based on tagged wild fish and we don't know the tagging fraction of the wild fish as they were passing downstream, we really can't estimate total production, and so we can't use that for a spawner recruit curve either. In terms of California coastal Chinook, so I'm just going to sort of move south-north along the coast through different ESUs. There was a recent paper that Mike O'Farrell and some colleagues, including me, put together. The region had sort of requested an update on, could we be doing more to actively manage fishery impacts on this threatened stock? And basically, Mike, please correct me if I'm mischaracterizing our report, but I think the report basically said, there really are not going to be suitable data to do a spawner recruit curve for California coastal Chinook or any population within California coastal Chinook. In terms of the Klamath Trinity, so, some people here are members of this Klamath River Fall Chinook work group that recently did do an updated spawner recruit analysis for Fall Run. That's using brood years 2001 through 2017. We discussed that the data to do a cohort reconstruction and therefore inform a spawner recruit analysis likely exists for Trinity or Klamath Trinity Spring Run, but not all of those data are publicly available. And again, we did think about the differences in life history, et cetera, between fall and spring run. And so given we had a pretty recent spawner recruit analysis for fall Chinook from the Klamath Trinity, and given the lack of public availability of some of these data, it didn't really seem realistic to try to do a Klamath spring run analysis. In terms of Southern Oregon and Northern California coast, for Rogue River Fall Chinook, there was an analysis done in 2014, but both the SSE and the STT endorsed the resulting FMSY estimate during a Salmon methodology review, I guess 10 years ago now. For Rogue River Spring Chinook, ODFW 2019 did put together a report. This was not something aimed at fisheries management. They were more just sort of interested in the productivity of the rogue spring population. So they fit a spawner recruit relationship, but they didn't report either FMSY or even all the parameters we would need to estimate it. And also their analysis did not include the effects of ocean harvest. And for most of the years in that analysis, it didn't have direct age data. So again, also factoring in the run timing difference didn't seem like that was going to be able to inform us. And then otherwise, for the Southern Oregon, Northern California coast ESU, there was a recent status review that I was a part of, Ole Shelton was a part of. So again, Ole, please correct me if you don't think I'm characterizing that report correctly, but basically that report kind of looked at all the available data, and other than the rogue, really did not seem like there would be suitable data for this kind of analysis for anything in that ESU. All right, then we started looking at the Oregon coastal stocks. And so the old proxy did use 3 fall run and 1 spring run stocks from the Oregon coast, all fairly dated. And all of those plus 11 more fall run and 1 more spring run were analyzed in this ODFW 2014 report. Again, this is not really a report that was aimed at fisheries management, but it did report essentially the spawner recruit parameters we would need to estimate FMSY from. But I would note that only a couple of the stocks included there actually have direct estimates of ocean harvest impacts. In many cases, they had to borrow ocean harvest impacts from the rivers they thought would be most representative among those that did have data. So here's just the results, or here's the key table from that paper, or that ODFW report. Don't really have much to say about it other than note there is a pretty wide range in the productivity parameters estimated, down as low as 2 for the Elk River, up to 12.8 for the Kena. But also, I'll point out, we had some discussion within the work group. If we did include these, should we include the spring run or not? And so luckily, the spring run estimates are kind of right in the middle of all the others. So it actually is not very consequential whether we include those spring run or not. And then in terms of more northern stocks, the work group did not spend a ton of energy on looking for new relationships for northern stocks, in part because of differences not only in the freshwater environment, but also some very different ocean distributions for stocks from California and Southern Oregon compared to stocks from the Columbia River North. Just to sort of quickly show what we're basing that on. So first, there's this paper by Lori Whitecamp, a very information-rich figure, but so different stocks or groups of stocks are arranged here on the left, going from the Central Valley at the bottom all the way up through the northern British Columbia coast. She actually had Alaska, but I cut it off to make it fit. And then for each stock, she's looking at what % of coded wire tags were recovered in different areas. So the black, gray, and white are different parts of California. the lavender, purple, and red are different parts of Oregon south of the Columbia. Orange is the Columbia, green is the Washington coast, and then blue and yellow is moving even further north than Washington. And so you see these Central Valley stocks. Most of the tags are being recovered in California, some are being recovered in Oregon, and very few are being recovered north of that. For the Southern Oregon and Northern California stocks, we see about half of the tags being recovered in California, about half in Oregon, and then only a tiny fraction further north than that. Then the Oregon coastal stocks are kind of a mixed bag. So let's see, this bottom row here is the Elk River Fall. And then this next row here is North Umpqua Spring. So they both have a tiny number of their tags being recovered in California, the vast majority of their tags being recovered in Oregon, and then a few tags further north. Compare that to here we have the salmon and the Trask, or maybe the Trask and the salmon, but regardless, those other Oregon coastal stocks, you see a little bit of tag recovery in Oregon, but mostly points further north. There's another paper by Shelton et al. That did somewhat similar analysis, although this also accounted for fishing effort. It also accounted for the time of year. Here we have stocks arranged from the southernmost to the northernmost. So SFB is Sacramento Falls Chinook. Then things like Northern California, Southern Oregon, Central Oregon, etc. Have ocean regions on the south, on the left, north on the right. And so again, if you sort of make a break point at the Cape Falcon, so sort of between the Northern Oregon coast and the Columbia area, you see once again, sort of regardless of the time of year, the Sacramento stocks are concentrated in Central California, and only a few are seen north of the Columbia. The Northern California, Southern Oregon stocks shifted somewhat north with respect to the Central Valley stocks, but again, are rarely seen north of the Columbia. Again, the coastal Oregon stocks are kind of a mixed bag. So the Central Oregon, I believe, is the Elk River, where it's sort of found a little bit of everywhere. Maybe in some seasons it's more like the Southern Oregon stocks. Maybe in other seasons it's more like the northern stocks. Northern Oregon, I believe, is the Salmon Fall. And so, there you see the vast majority seems to be north of the Columbia. And then same for every stock that originates from the Columbia north. Yes, you do occasionally see them south of the Columbia, but for the most part, they're in a very different part of the ocean. So given that ocean difference, we did not really do a comprehensive search for northern stocks that could inform this analysis. But just sort of for due diligence, I did take a quick look at the FMP to see if there were other stocks with stock-specific FMSY values that were either new since 2011 or had not been used in the original proxy. And so I did find there was one estimate for Grays Harbor Falls Chinook of an FMSY of 63%. Not super clear exactly where that came from, although sort of from context, I am reasonably confident it probably came from this 2014 Quinault and WDFW analysis. But given both the difference between northern and southern stocks and the lack of certainty on exactly where this estimate came from, the work group's not proposing including this in the new proxy for Sacramento Falls Chinook, but it is kind of reassuring that here's another sort of more modern estimate that is more in the ballpark of the FMSY estimates we're seeing in our more recent stocks we're proposing for inclusion compared to some of the older analyses in the original proxy. So having searched for additional or updated stocks, then the other question for us was, should we retain the other stocks in the original proxy that have not been updated? And so we came down pretty strongly that we would argue to exclude any analysis if the majority of brood years informing that analysis were from earlier than the late 1970s. In part, that's because that would be before there were coded wire tags. And so there will be very little to no empirical basis for the ocean harvest assumptions required to do those spawner recruit analyses. And also, if you talk to a lot of Pacific salmon ecologists, they'll talk about a regime shift taking place right around that time. So if you do exclude those, in our view, rather outdated analyses, the two analyses you might consider carrying over are the Columbia upriver summer for brood years 1979 to 1995, and the Deschutes fall Chinook for brood years 1977 to 1998. As we noted, these stocks do have a pretty different ocean distribution. These estimates are also not all that recent, although in fairness, they're not that much older than some of the brood years informing the rogue FMSY as well. So if you look at our list of proposed stocks that might inform a new FMSY, and so by extension also the SMSY SMP ratio, and just to be sure I did the algebra right, I also calculated each of these with different code and showed that they are always the same. So here's our list of alpha values, FMSYs for the stocks we're considering including, and the respective brood years and citations. Just looking at this table, a couple things that jump out. So if you look at these FMSY values, only one out of these 20 is larger than the current FMSY proxy, and only 7 out of the 20 are larger than the current FABC value. And so if the idea behind having this FABC be lower than FMSY and lower by the FMSY by a larger amount than it is for tier 1 stocks, because there's not a direct estimate, I think the sort of logic behind that would lead you to hope that therefore the majority of stocks that did not inform the proxy would at least have an FMSY above the FABC value that results from applying the ABC control rule to the proxy. So perhaps it's not ideal that only 7 out of 20 of these are larger than the current FABC. So if we do want to update the FMSY proxy, the sort of question is which stocks are suitable to include. And so, as we discussed, the Klamath Fall and Rogue Fall have the most similar ocean distributions, and probably in many ways, while they're certainly not identical freshwater environments, they may be more similar compared to the more northern ones. There is some degree of overlap with the Oregon coastal stocks. Although, we only have direct data on the ocean distribution of a few Oregon coastal stocks, so we can't really say on a river by river basis which ones are more or less similar. And we also may note that if we did include all of these Oregon coastal stocks, that would be either 14 or 16 data points coming out of this Oregon coastal area compared to only 2 from Southern Oregon and Northern California, which seems a little unbalanced if our real interest is being as representative of Sacramento Fall Chinook as we can be. So options that the work group discussed were either drop the Oregon coastal stocks or take the mean of all of the Oregon coastal stocks and use that as just one point to combine in with the other 2. One thing that occurred to me as I was putting these slides together is, well, we do have distributional data that suggests that the Elk Fall and North Umpqua Spring are probably relatively more like Sacramento in their ocean distribution than the other Oregon coastals we have data for. But of course, there may well be other Oregon coastal stocks that we don't have data for, but that do have distributions more like the Sacramento. And then, we did consider the possibility of including the Columbia upriver summer and Northern Deschutes fall. But, we're kind of, at least the work group was recommending against that, given that these analyses are somewhat dated and that they do have pretty different ocean distributions than Sacramento Fall Chinook. So sort of the work group's preferred, or most strongly recommended option would be just the Klamath Fall and Rogue Fall based on the similarity, but could see some argument for including, a single value to represent the Oregon coastals. There's sort of a trade-off here between being more representative versus having a larger sort of statistical sample size. And I see there's a hand up. I don't know whose it is, so just go ahead, whoever.
Sure, this is John Butter, California Department of Fish and Wildlife. Just the similarity in ocean distributions being kind of a basis for proxies. Was there, you're far more familiar with the kind of other factors that might be a consideration. I mean, we have all of these FMSY values that were under consideration from the various stocks. Had there been any kind of cluster analysis to evaluate what factors those FMSYs were associated with and the degree to which those factors are similar or dissimilar for Sacramento River as it is? Not sure exactly all of those factors would be, but you have, outmigration, you have the river factors as well as the ocean factors. Seeing which one of these are suitable proxies other than just ocean distribution. What other factors might you consider there? And have there been any kind of cluster analyses or meta-analytical kind of pursuits to evaluate, what is an appropriate proxy and what factors really matter driving that FMSY?
Yeah, thanks, John. So no sort of formal cluster analyses or that kind of thing. Informally, just looking back at, sorry, hope everyone's not getting vertigo from this. Informally, sort of my impression looking at this is you get the highest values from the oldest studies. And you also tend to get higher values for more northern stocks. But I also would not put a lot of faith in a cluster analysis done based on these values, because some of these values don't strike me as particularly credible. And again, maybe things were very different in 1955 compared to today. But the idea that the San Joaquin is more productive than the Feather or Upper Sacramento kind of seems backwards compared to current understanding of the system. And again, the data that would have informed this, I just really don't have much faith in the data that would have gone into these estimates in the Rice and Bickler paper. I mean, the South Fork eel, there is no way that was informed by real data. So yeah, long story short, that kind of formal analysis has not been done. And I'm not sure how valuable it would be given just, I'm not sure how much to trust some of these older values. This Cooney 1984, the main sort of thrust of that paper is we should really develop a strategy to gather data over a range of escapements so that we can estimate spinal recruit analyses better. So yeah, I don't know how much value there is in like beating these numbers into the ground.
Yeah, I mean, it's a tough one too, because I mean, as you note in your documentation, I mean, a lot of these things are, from a different regime from pre-1970s, et cetera. And, the recency of that information is somewhat limited. That kind of confines you as to what suitable proxies there might be in that regard. But yeah, I'm sorry, there's not more current information for you to work from. And I got to deal with what you have.
Yep. Thanks, John. I see your hand still up, but I assume that covers it for now. Yeah, thanks. Just a couple other additional caveats to keep in mind. And this one also, I think Brian brought up in the public comment. So, it does seem like the Klamath and the Rogue, in our opinion, are the best available proxies. That's not to say they're identical, and there are probably reasons to think that the Sacramento might be less productive than these two systems. Another flaw in pretty much I think in all of the analyses that went into the original proxy and in all of the analyses that went into this proposed update is that when they were estimating these MSY reference points, they captured the trade-off between reducing escapement in terms of how that affects future production and future yield versus current harvest. But by fishing harder, you not only reduce escapement, you also reduce by fishing harder in the ocean, you also reduce the age structure and size of fish, which is also probably going to have implications. If you just take a point estimate of alpha out of each study and use that to generate a point estimate of FMSY, that's not going to fully capture a lot of aspects of uncertainty in estimating alpha due to a thing called Jensen's inequality. So just try to briefly illustrate that in a very oversimplified way. So here I've just plotted the alpha value versus the FMSY value for each of the stocks under consideration for the updated proxy. But I just did that to get the curve. You can see there's a clear, direct, alpha exactly tells you what FMSY is going to be. It is a curved relationship. So just hypothetically suppose you thought there was a 50% chance that this was the correct alpha, that alpha was about 4, and you thought there was a 50% chance that the correct alpha was 9 point whatever this blue dot is. If you really thought there was a 50-50 chance that either of those two were the correct points, then if you want to come up with your best estimate of FMSY, you want to be taking the average FMSY value between those two estimates. You don't want to take the average alpha and then calculate FMSY from that, because that's going to give you a higher number. And due to the shape of this relationship, that's always going to happen. Also, just on the subject of uncertainty, so I love that the Klamath Work Group report did report a confidence interval on alpha. That confidence interval ranged from 2.2 to 10.1, which implies the FMSY confidence interval ranges from 0.35 to 0.78. So a very large confidence interval, and also the current proxy is right at the upper bound of that confidence interval. For the Rogue, they reported a Bayesian credible interval, little more restricted range, but also a lower bound. Corresponding to Rogue FMSY might be anything, and again, this is a 95% credible interval, so that is maybe a pretty strict standard, but so anywhere from 0.31 to 0.67. So those are various factors that lead to concern that this proxy may still be an overestimate of FMSY. That said, there are some factors that could argue in the other direction. So as I mentioned, some of the studies used in the original proxy did apply this adjustment to alpha. So the idea is, a lot of people think of the Ricker as being just recruits equal alpha times spawners raised to the negative beta times spawners. If you actually want to fit that in a statistical way, you have to specify some kind of error structure. Often we just assume there's this normally distributed error term that goes in the exponent. If you do that, then the median recruitment is indeed given by just the part without the epsilon that we're used to looking at. But the arithmetic mean escapement, is actually, there's this little correction factor of e to the sigma squared over 2. So you could argue that you should really be basing your FMSY estimate on this slightly larger value called alpha prime, where alpha is adjusted up based on your variance. This is all under the assumption that there's no observation error. And none of the studies that we looked at considered observation error in spawners. And most did not consider observation error in recruits, although probably, if anything, there's going to be more observation error in recruits than there is going to be in spawners. And so if there is observation error that you're not accounting for, that's going to give you too large of a variance to really be representing this process error. And so there's this, in my mind, kind of illogical conclusion that if you have noisier recruitment data, your response to that should be to fish harder. I'm not the first person to think about that. So here, the CTC 1999, which is cited for a couple of the FMSY values in the original proxy, talks about the same problem. There are ways, if you do have an estimate of measurement error, to build that into your analysis. But they say fairly strongly, just because you don't have an estimate of the measurement error doesn't mean there is no measurement error. And they say if estimates of measurement error are not available, there should be some rationale other than ignorance to show why you do the process error correction. And so I think that's something I would certainly agree with in terms of the accounting for measurement error side. See, did the hand just go up? Or no, just somebody added or dropped off. I'm still worried a little bit about even the idea of correcting for process error. So let's just suppose that somehow we did have a system with no measurement error. And so let's look at what are the implications of changing the level of process error variance while we hold the median recruitment constant, or the median productivity being sort of recruits per spawner before we get the effects of density dependence. So I'll start from what was in the old Klamath FMSY value, where they estimated an alpha of 5.92 and a variance of about 0.4, which leads to an alpha prime of about 0.72, and also leads to an FMSY of about 72%. So if you look at, this plot here is sort of saying, from year to year, basically, how likely are you to see a realized productivity that year of a certain value? And so here is alpha, that's the median. So half the area under the curve is to the left of that alpha, half the area of that curve is to the right of alpha. Alpha prime is the arithmetic mean of this distribution. Because it does have this very long right-hand tail, there is some small chance that you'll have a really, really high recruitment that'll drag up the mean. But actually 62% of the curve is to the left of alpha prime. So you actually expect that 62% of the time, productivity will be less than alpha prime is making you think. Compare that to if we essentially eliminate variance, if we have a super predictable, super stable system, in that case, alpha prime will be the same as alpha at 5.92, and FMSY will be 67%. Contrast that with what if we ramp the variance up? In that case, note that the mode of this distribution has actually been shifted even further to the left. Alpha prime is way out here to the right of alpha. The much larger value of alpha prime does boost FMSY to 0.85, but now 76% of the time you expect to have a productivity that's less than that alpha prime is telling you. So to me, the sort of core logic here seems to be the more variable your system is, the harder you should fish it, which maybe in the open discussion we can think about, is that really a logical conclusion? And then all of this have not yet started talking about, well, what if we start throwing some covariates in there? Thinking about how covariates affect this math really makes my head hurt. But I don't think it makes it any easier. And if anything, well, so certainly as you throw covariates in, you need to then worry about, well, should we be looking at things at the mean value of the covariate, at the median of the covariate? What if there are multiple covariates that covary? But all that aside, in general, it seems like if you have a good explanatory covariate, that will tend to reduce the variance. If you have by a lot, if you have a bad explanatory covariant, it'll only reduce the variance by a little bit. But then that also seems to set up another case of the sort of counterintuitive, the better you understand the system, the more informative a covariate you can come up with, potentially the less hard you would fish it. Whereas the worse you understand a system, the less you know what drives productivity, the harder you would fish it. So all that to say, I personally would maybe not want to use alpha prime, even in those cases where we could calculate it. If we did want to think about using it for any of the stocks in the proposed proxy, for the Rogue, their analysis does not report the variance. They didn't do their fitting exactly the same way that sort of justifies the derivation of the alpha prime calculation, although they do assume log normal error, so maybe it would apply. On the other hand, as I mentioned earlier, they actually did their analysis in a Bayesian framework, so maybe actually we should just be using their posterior mean FMSY rather than anything based on a point value of alpha. For the Klamath, the update in the Klamath workgroup doesn't report sigma squared, although I did check with Rich. I mean, it is available, but also it turns out we can back calculate what that variance must have been, because it does report an SMSY that is actually based on alpha prime rather than the alpha value that it reports. And so given the equality that FMSY is beta times SMSY, we can sort of say that had we known alpha prime for the Klamath, we would have come up with FMSY of 0.69. That said, one thing that some other papers will tell you is that if you do adjust alpha, you should also adjust beta, and that was not done here. And then there's the question of, well, but so that variance is including the effects of both process error and measurement error in recruitment. If you go back to the old analysis for the Klamath, they do sort of state one of their assumptions is that variation in realized recruitment dominates recruitment measurement error. And I guess therefore they can completely ignore it. But there's no real support for that statement other than saying, it's expected to be the case. For the Oregon coast, they do not report the variance. I'd also note, again, the Oregon coast analysis was really not done to inform fisheries management. It was done in sort of a population viability analysis. And again, one of the real insights from population viability analysis is that variance tends to increase your risk. And then, since we did not put, or since the work group was not really leaning towards putting either Columbia upriver summer or Deschutes Fall Chinook into the proxy, I didn't put them on the slide, but I did go back and look. So for the Columbia upriver summer, the CTC 1999 report sort of pretty explicitly says, we do not advise doing this correction for the system because we do not know what measurement error is, but we have a reason to suspect it is not small. Looking back at the Deschutes, that's the Sharma et al. 2010. The value that is in the proxy is just alpha, not alpha prime. Sharma et al. 2010 does report the variance. And I have to admit, in a quick read, it's not super clear whether or not they tried to adjust that for measurement error. There is various bootstrapping that they did for some parts of the analysis, but I'm really not entirely sure what the variance they report is meant to represent. So yeah, and then as I mentioned earlier, none of these analyses accounted for uncertainty in the spawning escapement. I'm not sure it's entirely predictable which way that would affect FMSY in every case. But given that there's none of these analyses have estimates of spawner escapement uncertainty, I don't think there's really anything in the short term we could do about that, even if we wanted to. So with that, I think that was my last slide of sort of real material to present. So I think the real key questions in front of the methodology review are, should we update the FMSY proxy? And so also by extension, that SMSY SMP ratio that's used for Sacramento River Fall Chinook. If it is appropriate to update the proxy, which studies should we use? And then also maybe it's worth thinking about what measure of central tendency among those studies should we use? If you go with the work group's recommendation of just Klamath and Rogue, it doesn't really matter. The median, mean, and mode will all be the same thing because there's only two of them. But it might still be worth clarifying what the best central tendency measure is, just to sort of set the precedent for how this might be approached in the future. And then there's also the question of how to treat alpha versus alpha prime. And that one I did not say is conditional on, do we update the proxy? Because I think it may be worth, again, thinking towards the future. In general, when we're looking at FMSY values, how should we be treating, alpha versus alpha prime? How should we be treating process error versus things like measurement error and just model misspecification? So that's all I have, and I'll throw it back to you for discussion, but I'm happy to answer any questions, etc.
Thanks, Will. I'll look for any hands.
Owen, do you want to be the one to call on people? I do see Owen's hand, but Oli's hand, but I'll let you handle it at this point.
Yeah, go ahead, Oli.
Great. I'm excited to see that there are two Owen Hamels on the line. Owen Hamel 1 and Owen Hamel.
Because my computer internet kept dropping, so I'm on my phone as well.
I hear you. Thanks. Well, thanks. That was a very thorough and informative presentation, so I appreciate that. My question is about related to one of the topics that Brian McLaughlin brought up earlier, which is hatchery fish. They were strikingly not mentioned in your presentation at all, and so was sort of wondering about how they fit into this, in your opinion, and how they affect or do not affect this estimates of MSY proxy and how we're interpreting it.
Yeah, thanks, Oli. Great question. And so, yeah, I mean, I think as Brian did allude to for the rogue, at least rogue fall, there's not really a ton of hatchery origin fish spawning in natural areas. So I think for the rogue, it's not really a huge issue. For the Klamath, if you go back to the STT 2005 that described the original Klamath analysis, that does sort of explicitly acknowledge there's this assumption being made that we're capturing the dynamics of a stock independent of hatchery influence. That said, there definitely are hatchery origin fish spawning in natural areas in the Klamath and among Klamath fall run. I think it's safe to say that that contribution is lower on the Klamath than it is in the Sacramento, so it's not as severe of a confounding factor. Mike or Candace or somebody may be able to speak more precisely to how different the hatchery contribution really is on the Klamath versus rogue. All that to say, I mean, I think it is an issue with the Klamath, which is again possibly suggesting that the Klamath FMSY estimate is probably higher than it would be had there been a purely natural Klamath system to estimate from. And then on the Oregon coastals, again, I think you probably know better than I do exactly what the hatchery influence is on one river versus the others. But certainly could be a factor to varying extents for those rivers also. And yeah, I mean, really, I think there's sort of this tough challenge. So I think really the only way you can derive like MSY reference points that like make good logical sense are either in a natural only system, in which case, how are you going to estimate ocean harvest to get at recruitment? Or sort of a really effectively done segregated system where you can really clearly separate out, okay, here are the natural dynamics, here are the hatchery dynamics. And unfortunately, I think sort of the systems that have the segregated hatchery system set up are probably not systems that are particularly similar to the Sacramento. So I don't know if that was helpful at all, but yeah, I mean, that's an issue, I think, for almost all of our reference points estimates. It's maybe a particularly acute issue for the Sacramento.
Yeah, thanks, Will.
Rich, I see your hand up. Go ahead.
Yeah, I just want to say I think it's a great idea to update the proxy with more related stocks. We ran into this issue with the Queets building plan where the same proxy value is used, and clearly, the Queets and the Sacramento are a lot different. So, and I do think your choices are reasonable. So yeah, I just think I think this is overdue.
Great, thanks, Rich. I agree. I don't think I have anything more to say than I agree.
All right, Jason.
Yeah, thanks, Owen. And, thanks, Will. That was incredibly thorough. I have sort of a conceptual question, maybe. Would it be possible to separate the impacts of ocean fisheries? And I'm using ocean fisheries very broad. I think probably mixed stock fisheries from more of the terminal dynamics in this. And so where I'm going, and I think I already know the answer to this, is could you eliminate the ocean impact or the difference in ocean distributions for those stocks and sort of partition that into two pieces?
Yeah, thanks, Jason. I mean, I think sort of the challenge, well, certainly we would expect like different ocean impacts for stocks that differ in where they are in the ocean. But I think we also would expect just different ecological productivities for stocks depending on where they are in the ocean. I mean, just things are going to be different if you're foraging off of Alaska than if you're foraging in Monterey Bay. Even in those cases where we can sort of just partition out what were the effects of harvest in the ocean versus what were the effects of harvest in the river, I still would think that, you know, fish that are experiencing the same Monterey Bay ocean environment may well differ in their productivity from fish that are experiencing, say, the Gulf of Alaska. Is that sort of what you're heading at? I mean, I guess one other thing is.
Yep, exactly.
Yeah, but just, yeah, also just sort of thinking about the representativeness question. And, you know, I did bring up the sort of concern about age structure effects, and potentially that's a bigger deal the larger the proportion of impacts that occur in the ocean, right? Because, I mean, there may well be age selectivity in the gear used in terminal fisheries, but at least terminal fisheries are only going to be impacting fish that would have come back that year, whereas, you know, ocean fisheries may be impacting fish that would have come back later, and therefore affecting the age structure that way. And so, yeah, I guess in my mind, that's maybe even another reason that stocks that, you know, experience, say, similarly high versus low ocean harvest rates. Well, I mean, ideally, I think we should be doing FMSY calculations that take age structure into account. But if we can't do that, then maybe that is also a factor that would affect sort of what might be more versus less representative. I think, go ahead, Mike, you're a moderator, so just go for it.
Okay, thanks. I was just thinking a little bit about this and curious your thoughts on it. You kind of covered it already, but maybe just circling back. I'm wondering if, you know, some of the far north migrating Columbia River stocks would be appropriate to think about, you know, for the proxy. You know, there is some overlap with, you know, distribution with Sacramento River Falls Chinook. You know, they come from a big basin like Sacramento River Falls Chinook. And I mean, I know the conditions are different, but, you know, if we eliminate these, you know, the far north migrating components, I just wonder if there would be some merit in that to have a little more diversity in the, you know, the suite of stocks that inform the proxy.
Yeah, thanks, Mike. And that is something that, you know, the work group discussed some. Unfortunately, it looks like Corey Green has dropped off, and I don't see. Oh yeah, Colin's here, and then I don't see Susan Bishop. And partly, I think Susan was sort of a little bit leery of wading into the Columbia just to sort of not step on toes of other sort of management entities. I think that was less of a concern to me. But, you know, there was some discussion between Corey and Colin about, yeah, sort of the same thing you were suggesting of, in some ways, are there parts of the Columbia that might be, you know, sort of similar freshwater to the sort of Sacramento system? I don't know if Colin wants to speak to that a little bit further. I mean, I think there arguably are some ways that parts of the Columbia are more similar. Well, certainly parts of the Columbia are more similar to the Sacramento River than some other systems are. But in terms of like whether the similarity was really on the same level as the Rogan Klamath, I think Corey would be great to speak to that, but unfortunately he's not here. And I think if Colin wants to add anything, you know, that is something the work group discussed.
Oh, thanks, Will. No, good question. You know, I tend to think about, at least as far as the inland environment, like stressors and limiting factors. There's definitely some stressors and limiting factors that are shared between the Sacramento and the Klamath in particular. I'm thinking about like sea shasta and water temperature related stressors, things like that. There's also, the migration corridor is fairly long and is now longer on the Klamath. Similar to what we see on the Sacramento. So those were some thoughts that kind of came to my mind as far as parallels in the inland environment.
Okay, thank you.
And I guess just one other thing I would add on that topic. I mean, I think one report that the work group has been putting together, not under methodology review, but just under progress report. I think the work group is absolutely supportive of at some point revisiting this. I don't think we want to be revising reference points every single year. But we also might want to do it with slightly higher frequency than we have been historically. So I think, it may well be worth highlighting, hey, maybe look into this particular stock, whether it might be suitable to use in the future. I think, we're also just sort of staring at, kind of as Rich said, like, we have something right now that is clearly out of date. Could we do better with infinite times and resources? Probably yes. But can we do substantially better now? And at least I would argue, yes, we can do substantially better now with what we have. Hey, Oli.
Yeah, thanks, Will. Basically for the Columbia, there's only a couple stocks that make any sense because they don't to look at for comparison because there's only a couple of them that don't go way north. But you guys probably already know that. There's also the rogue fish that they release into the Columbia, which go left and they go south. So those are weird too. But those are mostly hatchery fish. So my question is a little bit back to this hatchery stuff and this FMSY estimates are clearly designed to be used on the natural component of these stocks, right? And so my question is, let's say you have a river with a reference point that has 10% hatchery fish production, and you have another river with the same production components that has 90% hatchery production. Do you think the harvest and FMSY and reference points change for those two stocks for the natural component? Does that matter at all or not?
Yeah, that's a great question. And it's something I've been sort of thinking about and trying to get guidance from, sort of looking at the FMP. And I can't say that I've gained a lot of insight there. I mean, it is sort of, this challenge that I think people have recognized for a really long time. Like, there's a Robert Coate paper from, I think, like the late 80s or early 90s that sort of says, like, if you have a mixed stock fishery, and if you try to target FMSY based on the more productive like member of that mixed stock fishery, you're going to overharvest and like potentially not just overharvest, but actually drive extinct that less productive component. And so it seems like the FMP talks about, well, if you have a purely hatchery stock, then a lot of the FMSY considerations don't apply. You just want to get enough fish back to the hatchery. And then if you have obviously if you have a purely natural stock, then sort of FMSY is clearly defined in terms of natural fish. And I just can't see where in the FMP it says, how do you treat a composite? So it kind of seems to me like, if the idea is, and as you might know, I mean, I am not sure MSY is the right concept to be basing all our management on. But if our intent is to do the best we can to quantify what MSY is, it seems like we have to do that in a kind of theoretically coherent framework, which then to me is you need to do that in the natural component framework. So I guess, yeah, going back to your original question, I mean, if the natural component of those two different stocks or rivers, whatever you call it, if the natural component was equally productive in those two systems, then yeah, I think FMSY would also be the same. Obviously, that does have different implications in how much harvest of those hatchery fish you're going to have, unless you can somehow make your harvest selective on hatchery versus not hatchery.
Yeah, thanks. And that makes sense to me. I was just trying to work my way through what sort of the downstream ramifications are of those different scenarios, and I was similarly puzzled by it. So one, I think it's like a back burner. That's a bigger picture research thing over a longer time period that we're not going to solve today. But two, it also says that those hatchery fish in the river don't matter for productivity at all, right? So like they're rearing and whatever, that the rearing part is density independent, right? That's a sort of a assertion there in some ways. So I just think there's some super interesting interplay between the different processes here that does deserve some probably serious thought that's beyond this call. Thanks.
Yeah, totally agree. And yeah, I mean, there's also the issue of, even so, if you count the hatchery origin fish spawning in natural areas towards natural production, in a lot of systems, this may or may not be true of the Sacramento, but in a lot of systems, they're also going to be a different reproductive success depending on origin that, again, you kind of might want to be accounting for in the spawner recruit curve. Yeah, Jason?
Yeah, I was going to add a few thoughts about that. That's certainly something that we've struggled with in a number of Puget Sound systems, that they're now predominantly hatchery driven. And it's even on the natural spawning areas, we'll see 70, 80, 90% hatchery spawners. It's certainly not uncommon. We've still gone forth and tried to calculate a spawner recruit curve for those. And as you can imagine, the fit is, sometimes questionable, maybe all the time questionable. But, it's clear that, to me, it seems clear that those hatchery fish have to be accounted for somehow. They do produce quote unquote natural origin offspring. And that's when it becomes really tricky, is you've got hatchery fish that are part of your spawning escapement, and their offspring are now coming back as natural origin. And at that point, unless you have something like a parental brood tagging program, which I don't think exists for almost anything except for maybe some smaller steelhead populations, you can't track that. I mean, it's impossible to track. So you come back to, I think, a lot of the questions that you're wrestling with in the Sacramento is that they do contribute. We don't know how they contribute. There's a lot of research that says their contribution is probably a little bit less to maybe a lot less than what the natural origins contribution is. But it's just an incredibly difficult topic. And, Oli said it, you said it, we're certainly not going to solve it here, but and the way our management's set up, it's not clear how it should be dealt with, whether in those cases an F ratio or an F proxy is the right approach, or a spawning escapement is the right approach. I mean, there's just a lot more work to be done to try to understand how to manage those systems.
Yeah, thanks, Jason. So I'd agree with all that. And I guess one other thing to maybe think about is, the way we manage a lot of these systems, maybe in some ways, it's actually the escapement that we target that may be more important than the, exploitation rate cap that either actual exploitation rate cap, or at least the exploitation rate we use to calculate whether or not overfishing occurred. I mean, that's something that we're legally required to calculate and report on. But maybe what really matters is that our escapement goal meets the sort of concerns you're talking about, or at least factors them in. Not to say it's unimportant, just what harvest rates are, but well, yeah, I agree with everything. Add that layer too. Yeah.
Yeah, and that's exactly what we've ended up doing for a number of these systems is targeting a spawning escapement and using that as a metric. And certainly you still have to limit harvest rates. I mean, it's not a free-for-all, but it's delivering enough fish, hopefully a more natural type fish, to the spawning grounds that end up producing, and they produce at a hopefully sustainable level, or at least an increasing level as some of the habitat restoration work is able to take hold.
Yeah. Thanks, Jason.
Okay. Oh, there's another hand. Go ahead, Candace.
Thank you. Thanks, Will, for putting this all together and for presenting this all to us and for thinking about this so extensively over the last several months here and in the work group. Definitely, agree with the sentiments here that I think we should be up-to-dating the FSMSY proxy and, the other reference points used in the management of Sackball Chinook. And it seems pretty reasonable to me to be using, the stocks that you selected, Klamath and Rogue, to kind of be the best estimate of the derivation of that. And yeah, it's hard. It's hard to pick something given all the constraints to developing the stock's own stock recruitment analysis and reference points. And I just see what you had proposed in your paper as like the best logical steps forward to deriving this exploitation rate. I did want to, respond to, there was the comment about this could potentially be an overestimation due to the decreased productivity of the system. And yes, it's definitely true the Sacramento system is not the same as the Klamath and Rogue systems, and you probably have much different productivity from your natural area spawners. But also getting at, kind of the conversations we were just having about, your hatchery contributions to these systems. The exploitation rate that we're trying to derive it for, natural area spawners, natural area productivity. But then we're going to take that exploitation rate and I guess, apply it to the whole hatchery and natural component, both of those components. So your productivity of your hatchery component of the stock, which is significant, is likely very different from what your natural area spawner's productivity is like. And so the overall productivity of this hatchery and natural stocks combined is likely very different than just your natural only component. And that hatchery productivity varies from year to year based on your hatchery release practices. Are you releasing those fish in river, or are you trucking them all out to the ocean due to drought? So I don't think that, we shouldn't necessarily alter course by trying to get an estimate of that hatchery productivity and applying it to the whole stock combined. I don't think you could do that. I don't think you should do that. But I just wanted to flag that, while in some cases this could seem like an overestimate of the exploitation rate due to the productivity of the system, it's like, well, maybe you're actually getting more productivity of the stock as a whole due to your hatchery contribution to the stock. So it could go the other direction too. It's just the only thing I just wanted to point out.
Yeah, thanks, Candace. Yeah, I mean, I think, as we've been discussing, I mean, the big challenge is that under the current management system, we essentially have to assume that we're applying the same exploitation rate to both hatchery origin fish and natural origin fish.
Yep, definitely. And I don't think we should necessarily be going the other direction of the saying, what's the exploitation rate of our, or the productivity and exploitation, I'm sorry, productivity of our hatchery component and apply that to our natural component. That wouldn't be correct in that direction either. So yeah, no,
Yeah,
I agree with, I agree with, you know, I agree with what's proposed and moving forward in that direction.
Yeah, I should though correct myself. So we have to assume the same age-specific impact rates and the same river harvest rates, as Emily will tell us this afternoon. You know, if we're able to estimate maturation schedules, and if they do differ, then the overall exploitation rates are not actually necessarily the same, but definitely very limited scope to make those different by origin.
Okay, are there other comments right now? I'm not seeing any other new hands. Maybe we can go through, and I think it sounds like to me that 3 of these 4 questions here are, should be pretty easy to get answers for, maybe. And should we go through and try to answer those 3 and then discuss the 4th a bit? And so the one that I think is going to take a little more time is, you know, which studies and which values. But the, you know, question, should we update the FMSY proxy? I'm hearing generally that is something that people think we should do based on this information. Is there anyone who has a different opinion or would like to speak to that? I'm seeing some checks and thumbs up and no new hands. Candace, your hand is still up, but I assume that's just residual. All right, and then what measure of central tendency? There's been a question of, so there's the mean, the median, and the mode. I would note that the median is more typically, at least what I certainly argued for the SI index, that we should be using the median, and that's what we use in groundfish as the risk neutral point. Is there any other opinions or discussion on this? I see a hand.
What about the geomean?
The geometric mean. Yeah, that could be thrown in there too. Would that be of alpha or of the F value?
I'm thinking more in terms of the alphas. I think geomean is used with the log normal distribution typically.
Yeah, I mean, that should get you then at least theoretically close to the median.
Yeah, right.
Yeah, I would still argue for the median because it is the 50% point, which is, and risk neutrality is, you know, is sort of the mandate, but I realize there's also other ways to define risk neutrality. Again, does anyone, um, so any other thoughts on how we might approach this? Okay, anyone want to support the mean, mode, or geometric mean? Okay, hearing nothing. um, do you think we're ready to make a decision here, or do we need more discussion? Again, I'm putting forward the median as the appropriate value. Happy to either to make a decision now or wait on that. Not seeing
And I
any
don't know if you're,
objection. Mhm.
yeah, I don't know if you're following the chat, but there's support for it too. And
Oh yeah, I
Will
see it.
also,
Yeah.
okay. And Will
Okay.
notes that it's not all that different for the stocks we're talking about.
Yep. All right. All right. I assume then that we're good with the median. The third one that should be fairly easy is how to treat alpha versus alpha prime. Again, if we're going with the medium, we should be using alpha instead of alpha prime. And certainly with more variability, you're going to be having more impact. Oli says definitely alpha. Again, is there anyone who has a different opinion, or is everyone good with alpha? Happy to have thumbs up or comments in the chat. Seeing some thumbs up, not seeing any hands to object. So I think we've made those three recommendations. And so the final one is based on which studies. And so we've, heard the argument for the Klamath and the Rogue. Though it sounds like there may be more than one potential value to use, at least for the Rogue. And then also heard some arguments for using potentially all of the Oregon stocks as a single value, or all of the Southern Oregon stocks. And then, or also just adding in the elk and the North Umpqua Spring. That could also be as a single value, or weighted, so they are equivalent to a single value. So those seem like some potential options. I didn't hear strong arguments for using anything further north, or any other values that weren't included in the table. And go ahead, Oli.
Just trying to give you a break so you don't have to talk the whole time, Owen. But I guess I had a sort of, I'm fine with a fair number of these because I don't think they change the value all that much. So I think the Klamath and the Rogue seem great. My only question would be, this is probably going to have implications for all the other stocks we do these things for eventually. And if we sort of start picking and choosing which ones we're going to include here, does that mean every time we update one of these, we need to pick and choose the representative stocks all the way up the coast? Part of the appeal of having the single proxy that was derived in 2011 was that you have one analysis and then it's the proxy for all of these different things that you don't know much about. And so I guess I just want to flag that if you're going to pick and choose and do weighting and, do all that for this stock, it probably means for the other ones, you have to do the same thing, which is not necessarily a bad thing, but it is a lot more work. And so just want to make sure we put that on the table. Yeah, I'll stop there.
Okay, Will?
Yeah, and so at this point, definitely not speaking on behalf of the work group, because again, the work group is only proposing things with respect to Sacramento River Falls Chinook. But I think, Oli does raise an interesting question in terms of thinking about the future. So it may be informative to look at, here's the list of Chinook stocks that currently use the proxy. I'd also note, and Owen or John Budrick or somebody who knows more about groundfish can correct me if I'm wrong, but so I'm thinking there may be parallels to how there is a different proxy depletion or current over unfished biomass ratio used for flatfish compared to rockfish and groundfish. So maybe it would make sense at some point in the future. I'm not saying do this now. Come up with maybe a proxy for the northern stocks and a proxy for the southern stocks. I'd also note that some of the stocks that currently use the proxy actually have their own estimates now. So maybe we don't need to worry so much about how the proxy applies to them. But yeah, I think in terms of the work group, we're saying, here's what we think is the best approach for Sacramento River Falls Chinook. And you can sort of extrapolate from that to similar versus less similar stocks as you see fit or not.
Thanks, Will. Jason?
Yeah, I was just going to raise the sort of similarities with the groundfish stock definitions we're dealing with right now in terms of what do we do when we have no data? And we look for something that's got some reasonably similar distribution, perhaps similar life history characteristics. So adding something like that to our statement to say that when we do this for other stocks, we should be looking at such and such characteristics.
Okay. Thanks, Jason. Is there further discussion, or does someone have a proposal?
Oh, and this is Mike.
Yeah.
Mind if I jump in here for a second?
Please.
I don't know. I guess we have done these methodology reviews remotely before, but I don't know. I must have brain damage. I can't remember it very well. But I'm trying to figure out, just from looking at the agenda, whether this is, the SSC's time to talk through this, and then the STT will have an opportunity after that, or is this sort of free for all? I don't know if we've totally discussed that. I'm just curious.
I think it can be a free for all. I think it's I think if input from the STT to this discussion would be helpful, and I think we're just discussing it at the moment.
Okay, great, thanks. I guess in that case, I think we're on the same page here. When you look at the FNP, there's a lot of stocks that do use this, Chinook proxy, and they're pretty diverse. And so I'm just wondering if we might get questions from the council or something like that. That are we going to be amending the FNP to include this new proxy? Based on the discussion, I don't think that's the case. I think that the SAC work group is going to make the case, and please correct me if I'm wrong, that this only applies to SAC fall. But nonetheless, there might be discussion about applying this more broadly. for a number of reasons.
Yeah, thanks, Mike. And so again, I mean, the SACFAL work group has proposed a new proxy for use with Sacramento River Falls Chinook. Whether that would in itself require an FMP amendment, who knows? Would note there are some inconsistencies between what's in the FMP and what we're actually doing already for a few stocks. So I don't know that necessarily we would need an FMP amendment to change AF. Well, I know we don't need an FMSY proxy, or sorry, I know we don't need an amendment to change specific FMSY values. I don't know how the proxy would be handled. But so, and Galen also has a note in the chat, there are cases where what we do matches the FMP. There are cases where what we do don't match the FMP. And there's also apparently at least one case where what the FMP says does not match what the NOAA final rule says. All that just to say, I think we're just saying, here's a new proxy to use with Sacramento River Falls Chinook. I think it's definitely worth thinking about what should we be using as the proxy for some other stocks? How, shared versus stock specific could those proxies be? And again, a lot of these, I don't know about a lot, but definitely some of these things that are currently using proxies don't actually need to use proxies anymore because they have stock specific estimates. And some of these things that use proxies, it's maybe a misnomer to say they use a proxy because there's no exploitation rate to compare to the proxy. So yeah, I mean, we may be able to, I think for now it is very targeted to Sacramento River Falls Chinook, and it's possibly quite limited in terms of what practical implications it has anywhere else. Although certainly I think it's good if the FMP is accurate and what we're doing is consistent with the FMP.
All right. So, go ahead, Galen.
Yeah, I guess I also would like to echo Will's suggestion that, it gets awfully confusing when there's no final rules and FMP guidelines that either don't match up or like when we're just not following the FMP. So having some clarity from the council about what either establishing consistency or getting some clarification from the council would be really helpful in understanding like what the focus of the science side of this should be. And I don't know if the SFC is comfortable with that going in our statement, but it definitely has come up at a lot of salmon discussions over the past couple of years.
Yeah, I think clarity's always good. Robin?
Good morning, everyone. Relative to what's in the FMP and if changes are going to be made to this stock and whether or not it requires an FMP amendment, I think that it probably does not require an amendment, but obviously we want the FMP to be up to date and reflect whatever practices we are using. So perhaps in the statements or conversations that the STT and the SSC, Salmon SC and SSC have, just in those arenas, point out that, getting the FMP updated with this new information, even though it may not require an amendment, getting it updated as soon as possible would probably be beneficial so that we don't have things kind of waiting in the wings, if you will, for something bigger to come up that would require an amendment. I think that might be how we landed to where we are today with some things in the FMP not reflecting what the council has adopted and current practices are, and it just being the interval too long between FMP amendments without bringing in those edits that didn't require an FMP amendment, if that makes sense. So all of that in short, just to say, acknowledging that in your statements might be helpful for the council, just so that it may not require an amendment, but getting it in there as soon as possible is obviously the preference. Thanks.
All right.
And then for the sort of record, it seems like if both the SSC and the SCT have landed on the recommendation of not doing alpha prime and taking the median of rogue fall and Klamath fall, so that number to 2 decimal places is in the report. Do you want it to any more decimal places than that, just for the record, or it will officially be truncated to those 2 decimal places going forward? And I'm totally fine either way. I don't think we can really estimate it to even 2 significant figures, but just for the record, do you want anything more precise than 2 significant figures, or more pseudo precise than 2 significant figures?
Well, this is Mike. I agree with you, Will, and probably don't need to go out to any more precision than that.
I agree with that too.
Great. I'm just remembering that time when it was what mean of the prior on steepness do we use, and it actually ended up affecting the status, if I remember correctly. But it should not be an issue here, I would hope. But we'll just truncate it to 2 figures and we're done.
Rich, see your hand.
Yeah, that's a question for Will. So we decided to use alpha versus alpha prime. Did you use the alpha prime point estimate from the Klamath or the alpha to estimate FMSY?
I used the alpha and then I back calculated what it would have been with alpha prime. But
Okay.
so, and let's just double, triple check, because I know you're the one who came up with the value to begin with. But so, yeah, I used alpha of 4.7, which I'm pretty sure that's alpha, that's not alpha prime.
Okay, just want to make sure. Thanks.
And I think I'll stop sharing my screen unless people need it for some reason. And like I said, members of the public, if you want a copy of the presentation, just shoot me an email. So I guess I'll put it back on my email just for a sec. But yeah, hand it back to Owen and Mike.
Yeah. So, oh, Marlene, go ahead.
Also, I was just sorry, I'm curious. Does the SSE also have a copy of this available in their Google Drive folder for reference while you're crafting up the reporting?
Yeah, so there's a folder in the Salmon methodology review for like October 2024 Salmon methodology, and then in that I created a presentations folder.
Great, thanks so much.
And so Emily's presentation will be in there also.
Okay, so are we in agreement that the value from the Rogue and Klamath is the value that this subcommittee wants to put forward, or do we want to see anything else for November? I see a thumbs up, and Will, you
Yeah,
have your
and
hand up?
so yeah, I'm obviously recused from this decision here. I mean, I guess the only other possible decision point is, do we use the 0.56 for the Rogue that's based on the point estimate of alpha, or the posterior mean of alpha, or do we use the posterior mean of FMSY? I am going to suggest, although obviously I do not have a vote, I would suggest sticking with the 0.56, even though in a sort of theoretically ideal world, I do like using the posterior mean of FMSY better. I'm thinking about sort of the precedent of, if we want to be able to add stocks to this analysis going forward, or do the same kind of analysis, say for a proxy for another set of stocks. In most cases, we're not going to have a posterior distribution of FMSY to be working from. And also in somewhat of an attempt to be just sort of consistent with the approach taken previously, I'm kind of okay with using the value based off of the alpha estimate. That also means no new work for me, and so I'm happy with that also.
So that's a mean value rather than a median value for alpha?
That's a good point also, yes. So if you actually read the conference policy, they don't even say what the point estimates are. I mean, they give the numbers, but they don't say, are these posterior means or medians or whatever. But I asked Matt Folsom, and he said, yeah, these are posterior means. Again, yeah, if I were doing it myself, maybe I would take the posterior median. But sort of to some extent, I think for consistency with how the 2011 analysis was done, to some extent, I think we just go with what the individual analysts thought was appropriate. But yeah, I mean, it does create that issue. If you want me to ask Matt if he has the posterior median, I can try to track it down. He no longer works for ODFW. I'm not sure if he still has all the code, but he was pretty responsive when I talked to him last time. But yeah, personally, I don't think it's worth the effort, but I can see the argument for doing it, and I'm willing to try to do it if that's what people want.
Yeah, I think we can make a note about how we might do it in the future if we have new analyses to make sure we have the values we need. I agree, it's not going to make a big difference at this point for this particular stock. So I think that's fine as long as we make a note about how we would ideally like to, what information we would ideally like to have in the future. Yeah, so, and it sounds like everyone is comfortable with using just these two stocks to define it. So I think that's fine going forward, unless anyone has any further comment on that. And the only hand I'm seeing is Marlene's. Oh, that's gone now. Must have been residual. So I think we're probably just about done here. I'll give Mike a chance to say anything further, or he'd like to.
Yeah, thanks, Owen. I guess I would like to just check in with STT members if there's anything they would like to add before we move on. Any questions or this is your time before we move on to the next topic. And we will be working on our statement later today and in the coming days as well.
Mike, this is Candace. Follow-up question. This is moving forward with the recommendation of FMSY at 0.56 or 0.58?
Well, that's a good question. That's a good question.
I heard of the paper was 0.58, but I thought I heard 0.56.
I think the value is 0.58, but I'll let Will confirm.
Yeah, the value is 0.58. The reason 0.56 came up is, after we had settled on using the two stocks and after we had settled on taking the median of the estimates for those two stocks, then Owen had raised the question of like, what's actually the best point estimate to be using for the rogue? And so for the rogue, we used the 0.56, which is what comes from the alpha value we're using for the rogue. Potentially, we could have chosen to use 0.54 as the FMSY for the rogue, in which case then 0.58 would no longer be our mean and median. Well, I guess we only care about the median, but so yes, the median of what we've chosen to use for the rogue and what we've chosen to use for the Klamath, that will have a median of 0.58.
Got it. Thank you for clarifying that. Cool, thanks.
And again, if you look at the table, you come up with 0.585, but when I came up with a 0.58, that was to, it's something that rounds down to 0.58 if you do it to full precision.
I guess one other thing I just wanted to also, it just wasn't discussed in the paper or here, I just wanted to flag for the group, if that is our FMSY value, we will be managing, I assume, to an FABC of 0.52. So it's just something I was starting to think about, and I didn't hear any discussion about it in terms of like, well, what does that mean for the implementation and management? Just wanted to flag, although we're adopting, a exploitation rate of 0.58, that's not what, that doesn't mean that's what we would be managing at. That would be reduced by the 10% because this is a proxy stock for the Central Valley complex. Just wanted to highlight that for us, those that maybe haven't thought about that yet.
Okay, not seeing any other hands. I think we have wrapped this up, and I will hand it back to Galen and Mike, switching over from their other duties. So back to you guys.
Owen. Thanks, Owen, and thank you, Mike, and huge thank you to Will for walking through this. There's definitely a lot of assumptions to consider going into this, and you did a great job of framing it. I cannot have a side conversation with Mike O'Farrell to see if he is also ready for lunch. We have discussed the possibility of maybe doing the Salmon methodology review in person next year if there are enough topics to at least fill a day, because it's been a while since we've done this, and it definitely makes co-moderating a lot easier. We can see each other. So Mike, are you good with lunch break at this point?
I am good with the lunch break at this point. And since you just brought up the potential for in-person methodology review, I will just say my own personal opinion is I would much prefer that, for partly for the same reason you mentioned. It's nice to, look people in the eye, and see what's going on. And so I think that the more time that we can do this in person, the better for me, at least.
Yeah, so if anybody, this year would have been really hard for staff because of the super tight turnaround between the council meeting and this deadline, but hopefully we can all think about that moving forward. But yeah, we have Dr. Chen scheduled for 1 p.m. So I don't think it's practical to try to move things up. I think we'll just go ahead and have a almost hour and a half lunch. I know people have other parts of their job that they also need to be doing. So if everybody could be kind of back in their seats on their mics a minute or two before 1, that would be great. And we can get going then.
Great, thanks, Galen.
Yeah, thanks everyone.
Hi, Emily. Do you want to do a mic check while we're waiting for everybody to come back?
Yeah, how does that sound?
I can hear you loud and clear.
Great.
And it made you a moderator, so when it's time, you should be able to share your screen. But it's going to be a couple of minutes before everybody's back and ready to go, so you can chill out in the meantime.
Okay, great. Yeah, I see that that's an option now. So.
Hi, everyone. It's 1 o'clock. Mike, are you back?
I am back.
Okay, and then Angela and Robin.
Robin's here.
Great. So Emily is here also. We did a mic check. And yeah, welcome to Emily, our special guest and recent recipient of or earner of her doctorate. Congratulations. We're excited to see your work. And I have Tommy Moore and John Kerry as the discussion leads and Oli Shelton as the rapporteur. Oli, are you here? Hi, Oli. Okay. Unless Mike has something to add, then we will turn it over to Tommy and John.
All right. Yeah. So this session run, at least for from the facilitator standpoint, similar to last one. Emily has prepared a presentation on the cohort reconstruction, and then John Kerry and myself will be moderating or facilitating discussion. And I think we all know how this goes, so I'll pass over to Emily if she wants to get started on her presentation, unless you have anything you want to add, John.
No, thanks, Tommy. Just a thanks to Emily, and maybe we should check and see if she has a preference on whether you want questions during, after, or what.
If there are questions, questions clarifying stuff, I can answer. Feel free to interrupt, and I can answer them then. And then, if there's things worth discussing, then maybe we could talk about that at the end.
Sounds great. Thanks.
Okay, let me share my screen. All right. Hopefully that looks good.
Yep, looks good.
Okay. All right. So, hey everybody, thank you for having me come and talk about this paper that we recently are putting together on cohort reconstructions for Sacramento River Fall Chinook. I'm going to talk a little bit about the methodology here and then also compare it to the Sacramento Index and talk about differences in the methods and then also differences in some of the output and some points coming from that. So just a little bit of background on the current index or current metric of abundance is the Sacramento Index, which is an index, so it's not a specific estimate of abundance. The index is meant to represent both the abundance of ocean abundance of Chinook salmon at the start of the biological year, which is September 1st. And the index is also meant to represent what the escapement would be the following fall in the absence of fishing in the current year. So the current index is meant to represent both of these terms. And so how the index right now is meant to represent both of these terms is that the index is a summary of ocean harvest, river harvest, and escapement. And the sum of these together is the ocean abundance. So can imagine if there were no ocean harvest or river harvest to occur in the current year, the concept is that all of these fish in the ocean would then be escapement, and so that's how the index is meant to be both abundance at the start of September 1st and then also escapement absent fishing in the current year. But this model does not include a couple of key biological facts that are possibilities, such as the possibility that fish in the ocean might not escape in the current year. And so there's the possibility that fish can remain in the ocean for another year. There's also the fact that the possibility that fish that are part of the ocean abundance at the beginning could also become natural mortality, and that's currently not represented in the Sacramento Index. And then another key component not represented here is the possibility of fish that are impacted, that are not harvested but are still contacted by the fisheries that are ultimately impacted. So these are some of the key biological dynamics that we're trying to include, that we included in the cohort reconstruction, that fish can become, that there's the possibility that fish will not mature and they won't be harvested and they'll remain in the ocean for another year. There's also natural mortality is an ongoing process that happens during the year. And then for ocean impact, also breaking this down into fish that are harvested, but then also trying to estimate the proportion of fish that are not landed that become mortalities. So the cohort reconstruction, a little bit of background, it estimates abundance, so it's not an index. It provides separate estimates for abundance at the start of the biological year, and then also an estimate for what escapement in the absence of fishing in the current year would be. So these two are two separate estimates that are produced in the cohort reconstruction. And because the cohort reconstruction estimates the abundance of a cohort over time, it also allows us to estimate a whole variety of important biological rates, such as out of all the fish in the ocean at a given time and the fish that mature, what is the rate of maturing at every age. Also, this analysis allows us to estimate what the early life survival rate is. We could also estimate the specific impact rate at each age using the cohort reconstruction. And then also with the cohort reconstruction, we can also calculate what the fishing impact is on a cohort over its over the cohort's lifetime. So the cohort reconstruction, the methods that we have in this report are really similar to what's being used right now for Klamath River Fall Chinook and has been in place for decades. And the possibility of doing a cohort reconstruction is a major reason for why the constant fractional marking program was in place since 2006, and then also sampling for coded wire tags in river and also on the spawning grounds, and then also the possibility to use the scale data has also been a motivating factor for collecting and aging scales from spawners, and this has been done since 2010. And so now at this point we've reached around 10 plus years of data to perform cohort analysis for multiple cohorts. And in our report, we did analysis going all the way back to when prior to constant fractional marking and prior to scale and aging of scale aging as well. But the analysis I'm going to talk about today, or the most of the results, are going to be from this range where we have all of the data available from 2010 to 2019 run years. So just kind of a schematic of what the cohort reconstruction is trying to capture, or the processes that it captures. You can imagine a cohort in a span of a year. A fish in the ocean can experience multiple different, a whole bunch of different possible fates, including captured by the ocean fisheries or released and still impacted, to also natural mortality, maturation, or river harvest, or they could also remain in the ocean from to the next year. And so the cohort reconstruction essentially works backwards in time and reconstructs all of the possible fates to estimate what is the ocean abundance at the beginning of the time period. So I have an equation here that's showing how the current abundance is calculated is based on the abundance in the following time step, plus all the different possible outcomes of the cohort in this time step. And the reconstruction starts at the final age in which we see every cohort, which is usually age 5 for Sacramento fall fish. And then it works backwards all the way to the beginning, or wherever we want to start with, which is when fish first enter the ocean at age 2. This is kind of showing an annual schematic of what's happening, but for our analysis, we did things on a monthly time step. And so on a monthly time step, when fish are not spawning, maturation would be 0, or if the fishery wasn't occurring in a specific month, then fishery impacts would be 0 for that month. Some of the data that was used in this cohort reconstruction is coded wire tags for the hatchery fish. And so for the coded wire tag data, we did coded wire tag expansion rates. And so you can imagine that if we have a single coded wire tag that was recovered, there's an associated sampling rate either on the spawning grounds or in the fishery of the rate in which the fisheries are sampled. And then this was how we expanded a single tag recovered to estimate how many tags there were present in total. And then there was a second expansion to account for the tagging rate. And since 2006, it has been roughly 25% for all batches. And so, for example, if we were to expand 4 times or 1/4 of the tagging rate to estimate the total number of coated wire tagged fish that were present, or total number of hatchery fish from that batch that were present. For the natural origin fish, however, the natural origin fish are not marked or they're not tagged, and so there's not coated wire tags to inform their harvest and their escapement. And so for the natural origin fish, what we do have information on is scales that were aged by CDFW's Ocean Salmon Project. They aged scales from these unmarked fish to, and we were able to estimate what the age-specific escapement of unmarked and untagged fish were from the unmarked scale samples. And then from the ages of the scales, we also conducted a Kimura-Chikuni age correction adjustment, and this basically adjusts the age proportions that we estimate from the scale data based on if there's potential aging biases that exist. So from coated wire tag samples, we're able to compare the known age from coated wire tags to the red age from the scales to get a sense of if there's any aging bias that exists across the unmarked samples, and we made this adjustment. And this is very similar to the same method for age-specific escapement of scales in the Klamath River Basin. So these scales that were aged are unmarked fish, and so these unmarked fish could either be natural origin fish or they could be the unmarked hatchery fish, which for a tagging rate of 25% is 75% of hatchery fish that are unmarked or untagged. And so unmarked escapement could be a combination of both these hatchery unmarked fish and then also natural origin fish. And so once we broke down the unmarked escapement to each different age, we subtracted the amount of fish that we estimate were unmarked hatchery fish based on the tags that we did recover and the known tagging rates. We were able to estimate how many unmarked hatchery fish at each age we estimate were out there, and we subtracted that. And the remainder we estimate is the unmarked natural origin fish at each age. So for the cohort reconstruction, there was a lot of different metrics that we used to quantify exploitation. So from the reconstruction, we quantified harvest, and then from the coated wire tags, and then also applied that harvest rate to natural origin fish. We also estimated impact, which includes release mortality and drop-off mortality compared to harvest. And then we were also able to estimate an age-specific ocean impact rate. And then we calculated a spawner reduction rate, which is 1 minus the escapement observed over the potential escapement if fishing had not occurred in the current year. And so this spawner reduction rate, we calculated it by run year or return year. And we reported 2 metrics of spawner reduction rates. One is if there was no fishing to occur in the current season since September. And the other one is that if no fishing were to occur at all on the cohort. And so for the first one, this is more similar to how the FMSY is derived, what the impact would be relative to if there was no impact that was occurring. And then the second term, the one where there's no fishing at all for the time period of the cohort is always going to be greater because there's more fishing impact that's considered in the SRR than the SRRY. And how we calculated these two is basically through the reconstruction, going back since September, and then looking at what escapement would be since if no fishing were to occur since September, or going all the way back to the onset of the cohort when they first entered the ocean, and performing the cohort progression through time and looking at what escapement would be if there was no fishing impact at all on the cohort. I just saw that someone raise their hand. If it's about this, I can try to answer that now.
Yeah, thanks, Emily. It's Will. Just quickly, and sorry not to catch this earlier, I think you described the difference in how the SRR sub Y versus SRR are calculated. You described that entirely correctly, but actually I think it's the SRRY is actually more like what we use the control rule for. Where that's the control rule is really about the exploitation rate that's going to occur, or the exploitation that's just going to occur during this current calendar year. But really, in terms of how FMSY was originally derived, that really is about total reduction in the cohort. So I think the FMSY derivation is actually more like SRR, but then the exploitation rate we want to get out of the control rule and use in annual planning, that's more like SRRY.
Okay. Okay, yeah, thank you for that clarification. Additionally, in our report, we could also include fishery information north of Cape Falcon, which is currently not included in the SI. And so in our report, just for parallel comparisons, we reported most of our estimates without fisheries north of Falcon, except when we note for compare what it looks like if you were to include information north of Falcon. And in the report, I've included kind of parallel analyses for if you were to not to include fishery information north of Cape Falcon. So in this analysis, there are certainly lots of different uncertainties or errors that could exist within the analyses, and a few of them that we considered. One of them that we considered was thinking about uncertainty from expansion due to sampling. And so, as I mentioned, the sampling fraction, we use that directly to expand the number of coded wire tags that we estimated were present, but the actual number of coded wire tag fish might not be exactly what the expanded number is. And so we quantified the uncertainty from sampling, from the sampling fraction by resampling how many unrecovered tags there may be for every tag that was recovered, following a binomial distribution to estimate the number of unrecovered tags 1,000 times. And then another source of uncertainty that we factored into this analysis is uncertainty due to sample size in the scale ages. And so this was a matter of bootstrapping the samples every year for every tributary 1,000 times to quantify the amount of uncertainty due to sample size. And for both of these draws, we performed cohort reconstructions on 1,000 times for each of these iterations to characterize the uncertainty from the scale aging and then also from the coded wire tag recovery. There's lots of other uncertainties that potentially exist, and this is not an exhaustive list. And so some of the things that we thought about but did not include here is uncertainty around natural mortality. So natural mortality in our analysis was fixed at each age after age 2. And then we also had fixed non-mortality rates. They were different rates for commercial and recreational fisheries, and for recreational fisheries, they also varied across seasons and across regions, but they were fixed rates with no error associated with them. And then natural origin fish we assumed had the same age-specific ocean impact rates as hatchery fish because there was no coded wire tagger hatchery or harvest information associated for the natural origin fish. So in terms of outputs, comparing the cohort reconstruction outputs to the Sacramento index. So as I mentioned earlier, the Sacramento index is representing both potential escapement absent fishing and ocean abundance on September 1st. So I have here comparing those two metrics from the cohort reconstructions to the SI. When we compare the potential escapement to the SI, the SI is overestimating what the potential escapement would be absent fishing, which means it's more difficult to achieve the target escapement based on the SI information, since the potential escapement absent fishing is lower than the SI. And here on the right, I basically have what the values would be if we were to use potential escapement absent fishing instead of the SI. Overall, that we would have smaller values or a reduction in this value from using potential escapement absent fishing instead. Some of the reasons why the Sacramento index is greater than potential escapement is that the index includes harvest of fish that might not have matured in the current year. They might have stayed out into the ocean and matured in the following year. The way the SI ocean harvest is calculated right now, south of Point Arena, is taking total ocean harvest south of Point Arena and subtracting Klamath hatchery and natural origin fish, and then also hatchery origin stocks from California. And so natural origin fish in California, including California coastal Chinooks, San Joaquin fall, spring run, Central Valley fish. These fish are still remaining within in the ocean harvest for SI, and so that also leads to greater numbers overall in the SI than what would not be included in the cohort reconstruction. And this, the way that the harvest is calculated south of Point Arena can also influence how we are estimating ocean harvest north of Point Arena as well. And so this fact influences both estimates south and north of Point Arena and increasing the SI compared to potential escapement. In terms of the Sacramento index versus ocean abundance starting in September 1, it's much, overall, it is underestimating what ocean abundance is starting on September 1st. And so these numbers on the very right is basically showing if we were to switch from the SI to this estimate of September 1 ocean abundance, we would see fairly large increases overall in this metric of ocean abundance in September 1st. And some of the key reasons why the September 1st ocean abundance is a lot greater than the SI is that the cohort reconstruction is including fish that is accounting for fish that are natural mortalities throughout the year, and that's added back into the SI. And then also fish that don't spawn in the current year is also part of the ocean abundance that we factored in the cohort reconstruction. That's not part of the SI. And then the ocean abundance from the cohort reconstruction also includes non-landed mortalities, which is not included in ocean harvest in the SI right now. Comparing the SI exploitation rate to the spawner reduction rate sub Y, which is the spawner reduction rate in the absence of fishing in the current management year. Overall, or actually in every single year, the SI exploitation rate, which is here in black, the point estimates, are greater than the spawner reduction rate. In without fishing in the current year, and this is partially because harvest in the SI right now is including harvest of non Sacramento fall fish, such as the natural origin stocks in California, is one of the reasons why. So just to close things out with some recommendations or some conclusions from comparing the Sacramento index to the cohort reconstruction results, is recommending that the cohort reconstruction metrics be used for the postseason assessments. For example, the main thing in the postseason assessments would be the exploitation rate, and so using the spawner reduction rate that we have calculated here as the exploitation rate. Just want to point out that there may be potentially time lag with using the cohort reconstruction metrics, both in terms of practical time lag with getting the data needed for the cohort reconstruction, but also some biological constraints of using the cohort reconstruction, given that there's incomplete cohorts. But this is a similar issue that other stocks that do use cohort reconstruction metrics now have ways to work around. And then also including non-landed mortalities in the cohort in the cohort reconstruction metrics and the postseason assessments. And then another point that we test including versus not including is impact north of Cape Falcon as well. Another recommendation is reparameterizing the harvest model based on the cohort reconstruction output. And so this includes the ocean abundance over time that we estimate in the reconstruction, but also the exploitation rate that we calculated through the reconstruction instead of the SI's exploitation rate. There's also the possibility for exploring age-specific forecast models, like what is used for the Klamath River fall Chinook population, or also just instead using the metrics of abundance that are from the cohort reconstruction instead of the Sacramento index. And then lastly, a lot of the biological information that we've gained from the study, there's about 10 years or so of data to and that's constantly growing as more and more years pass by. And so this gives us an opportunity to better understand the SMSY and the conservation objective. And so this output could be important for better estimating these parameters too. So I'll just finish the presentation just by acknowledging and thanking everybody that has been involved in collecting the data that was used for this analysis. So CDFW, Pacific States, and Fish and Wildlife Service for tagging and monitoring, collecting the samples. And then specifically the Ocean Salmon Project, they've been really important collaborator in helping us understand the data and helping us access the data, and especially wanted to thank Candace, Keelio, Pete, Grace, and Audrey for being involved in this work. And so I think that's all I have for the presentation. I'll just go back to the recommendation slide, and we could, if people want me to go back to other slides too for the discussion, can do that too.
Great. Thank you very much, Emily. See if anyone has any hands coming up or any questions for Emily or discussion. Go ahead, Jason.
Yeah, thanks, Tommy. And thank you, Emily, for a very nice presentation. I would like to go back to the coated wire tag expansions you were doing.
Okay.
And my question is that, I don't typically make those expansions. I typically pull the value out of Armis. It seems like you might have been making those expansions yourself. And the example that you gave, you end up with a whole number. If you pull them from Armis, I've actually can count on my hand the number of times I've seen a whole number. It's typically a fractional fish. How do you deal, or how would you deal with that?
Yeah, no, I do use the expanded value in, I think it's like estimated number in the RMIS database. So this is just a toy example of like a simpler case. And so, yeah, most of the time it's not a single number. And so, if we're doing point estimates, we would not get whole numbers most of the time. If we're doing the resampling, though, because it's a negative binomial distribution, we do have get a draw of a integer from the negative binomial distribution, and this is done 1,000 times.
Perfect. So, and I think I know the answer to this. Why a negative binomial versus just a Poisson?
I think conceptually, a negative binomial distribution is representing successful and unsuccessful draws. So, in terms of describing the number of we viewed the non-recovered tags as the non-success, and the single tag recovered as the successful draw.
Go ahead, Candace.
Thank you. Yes, Emily, thank you for the awesome presentation. And thank you for taking this data and seeing it through to the cohort reconstruction. That's not something we've been able to do over the last, couple of years, but we're so glad to have somebody, take this data, use it, and, present it for potential use in management. Exciting times. But anyway, I had a question about the sampling uncertainty. Did you look at, the uncertainty with regards to the sampling expansions for different types of sampling, like ocean versus inland versus hatchery versus carcass survey and that sort of thing?
No, we didn't. So I know that that the spread could be pretty wildly different. Like at the hatchery, it's like very low, the number of unsampled fish, and then some like less sampled rivers is like real, like 1 in 20 or even greater than that. And so there's definitely a big spread in terms of the sampling fractions we see, and there definitely is like some different recovery types are very low and some are very high, but we don't do anything separate or different for the different recovery types.
Okay. Yeah, because that's what I was, although we haven't, calculated, measurements of uncertainty around, these sampling fractions, what we do regularly look at in our other cohort reconstruction and just all of our data that we work with coated wire tags. I mean, Ocean Salmon Project is looking at these generating these sampling expansion factors based on the ocean data, inland data, and uploading that to RMIS. So what I'm doing is I'm often looking at those expansion factors and just identifying any that might be, just really extraneous or whether or not they, kind of fit logically. So I'm just thinking about ways that, quantifying uncertainty for the sampling fraction that could be used. And I guess I'm doing that in a less formal way already by reviewing expansion factors. But Was there a thought of like how this could be applied in the cohort reconstruction or how you're using data?
Well, I guess the advantage of characterizing so with the sampling fractions, the greater the less frequent the sampling, the more error or bigger range of possibilities there are. So if it's if there's a very high sampling frequency, the range of error is very narrow compared to if there's a very infrequent sampling. But I don't know if I have any thoughts on like quality control of like if there's very high, very infrequent sampling, so very high expansion. And I do think that that's it is like kind of a concern or just something that we've discussed before. If the sampling fraction is very, very high, if that's reasonable. But on the other hand, I think if it's very high, even if it's not reasonable for one sample, it could balance out overall even though like one sample might seem unreasonably high, it would balance out, I think, in the end.
Yeah. Okay. Yeah, I was just wondering what the idea was for the potential application of like the uncertainties balance and things for the sampling fraction. But thank you.
Yeah, I mean, I think that you could potentially compare like how much uncertainty exists at different sampling rates and try to see like what would be like an acceptable amount of uncertainty and what would be like a good target for sampling fractions.
Okay.
Yeah, thank you.
Thanks.
Any more questions for Emily? Discussions, thoughts, concerns? Otherwise, maybe we'll go back to the recommendations slide and see what everyone's thinking about those. Go ahead, Ole.
Yeah, thanks, Tommy. Again, thanks, Emily, for a really nice presentation. I think about codewire tags a lot, and so I have lots of thoughts. You don't need to know most of them, but I was wondering a little bit about some of the other data that shows up in here. Specifically, the way you set up this backwards cohort reconstruction is by assuming those escapements and things are known and perfectly known. And I was wondering, one, make sure I have that right. And I was sort of wondering if you had thought about or considered putting in any of those things as sort of estimates or uncertainty around them or any of those kinds of aspects. And so that probably is for the escapements, so it's the counts in the river. It's probably for the fisheries as well, because those are not actually perfect counts. And so just sort of, did that come into consideration at all in your doing this work?
So there is some elements of uncertainty that are included in the escapements and then also ocean harvest. So that's the uncertainty around the scales and then for the counts of hatchery fish, then there is some metric of uncertainty for the abundance of coded wire tag for hatchery fish. That part there is uncertainty for, but then for the counts that we get from like cowfish and stuff, there is no uncertainty there. So that abundance there, that is like a fixed number that we're subtracting the hatchery fish from to get the natural origin fish. So does that
Yeah, totally. No, I totally, that makes exactly sense. It's sort of what I thought you did. But basically, it's like if you have a total number of fish that are escaped, right, and then you're trying to partition them amongst your various groups, or your various tagged, untagged, natural, whatever. But you could also imagine saying, well, that total number is plus or minus 10%, right? Or plus or minus whatever a reasonable rate is, and I will defer to the California experts about that. So that was just sort of mostly just sort of flagging that, and like maybe it matters, maybe it doesn't, but it is another sort of set of things that might be worth at least thinking about for the future. And if people think that their uncertainty in that rate is 0%, then you don't have to worry about it. But I'm pretty sure it's not zero. So that was just that was just sort of comment number one, and maybe somebody else who knows more about this California data than I do might comment on that as well. Like Will has his hand up, for example.
Yeah, well, I'm not saying I know more about the California data than you do. And I definitely sort of share the kind of concern or at least question that you're raising. And I do think it's worth looking into that, especially, yeah, if we did have estimates of the uncertainty in the escapements. And I think in a lot of cases, the escapement estimates are basically coming out of, mark recapture models applied to carcass recoveries. And, you can certainly question how closely that actually matches, like how closely we're actually adhering to the assumptions of those models, but they could, at least in theory, generate uncertainty intervals that could be interesting to look at. One additional challenge, though, that would pose is, as Emily talked about, we take this fixed total escapement and subtract off our expanded hatchery fish, and therefore, sort of infer the natural origin fish. And we're doing this also for each age class. And so one complication that we would just have to figure out how to deal with is, I imagine it, say, like if we, did all the bootstrapping we're already doing on top of like a bootstrap of what the total escapement was, then already every once in a while we'll get negative numbers for the rare age classes of natural origin fish. And I expect we would just run into that even more often if we are also bootstrapping or doing something else for the uncertainty in the total escapement. Not to say that's an excuse to ignore the uncertainty, but it is sort of another challenge we'd have to work through before we could do that.
Yeah, totally. Yeah, the practical implications are not trivial, but I just sort of wanted to make sure we mentioned it. And like the other side of this is that you're doing all these simulations to do uncertainty that are independent, right? So you do this chunk of the river with a negative binomial expansion, then you walk down the street and you do the next chunk of river with a negative binomial, and those are independent from one another, right? And like there's reasons to think that they're not, right? Like probably the age structure or the number of proportion of hatchery fish in one stretch of the river is at least partially related to the hatchery fish in another stretch of the river. But whatever, it's better than not dealing with it at all. So the other part of this that's sort of related to that independent part is that what you're doing when you're doing these independent negative binomials is you're approximating a multinomial, right? Or you're approximating a Dirichlet multinomial, to be specific. And so there's actually probably an argument for just doing the Dirichlet multinomial itself instead of marginally approximating it from the independent draws. And that's a deeper, that's like a weird statistical result, but sort of worth thinking about it, because when you do things jointly, you avoid the weirdness of accidentally getting things that sum to something larger than your total number of fish. So you avoid that exact problem that you just mentioned, Will. So anyway, that's more of a comment than a question. Maybe somebody can chime in if somebody has a response to that. So I see Candace has her hand up.
I don't have a response to that question, but I do want to just provide a little bit of context on like the layout of the sampling in the Central Valley, I guess, as best as I can. I mean, it is pretty extensively sampled in all of the, natural areas, hatcheries. You have ladders and direct count. But for our natural area escapement surveys, they're pretty well sampled. Doing mark recapture surveys, often carcass survey with the Cormac Dolly fever, mark recapture estimation methods. But each survey lead is responsible for generating their specific areas escapement estimates, and that's there are efforts to generalize that across the Central Valley, but it is done by different agencies, U.S. Fish and Wildlife Service. CFW, East Bay mud. So there is some standardization across the valley, but it is up to, those general population estimates are up to individual survey leads. If that helps context for you.
Yeah, super helpful for me. And don't get me wrong, I totally appreciate the complexity, logistical and otherwise, for how do you put all these things together. So I'll stop talking in 1 second. But the only other thing that I wanted to mention that I sort of saw from reading this report is that there's this like minor point of how you're doing expansions, in that you treat things that you observed as uncertain. So like if I saw at least one tag, I'm gonna negative binomial it and generate some expansion factor. But if you see zeros, it was a true zero, right? Because you never expand your zeros to be something other than zero. And so that's not necessarily a big deal for this stock, probably, because most of the you aren't going to end up with too many zero observed. But it is something that's sort of worth just sort of noting, that you're treating some of your observations significantly different than you're treating some of the other ones. So but I'll stop talking, and maybe other people have comments.
No, I see what you're saying, and I also like your pointer suggestion about the using a multinomial distribution instead.
Yeah, and don't rewrite your thesis. Let's be clear there. Not going to suggest that at all. But I'm just saying that, like, moving forward, there's some ways to avoid the weirdnesses where you like have negative numbers and things like that. So.
Go ahead, Will.
Yeah, and yeah, thanks, Oli, for bringing up the issue of zeros. And yeah, that's something I've been struggling with also. And I've sort of come up with an approach for dealing with it that I used in one paper based off of ocean harvest. But the worrying aspect of at least the idea that I came up with is that it's sort of very sensitive. Well, how many, that's a good way to phrase this. Sort of the more stratified your sampling program is, it seems like the more zeros you potentially have to account for. And I've been struggling to come up with a way of how do you not sort of inflate your estimate of how many things you didn't see the more you stratify your sampling scheme. Although maybe it's fair to say the more stratified your sampling scheme, the more things you probably missed, but maybe not. So anyway, just very much do agree with, like, we need to figure out what to do with zeros, but I would love a very clear, easy solution of what to do with them.
Is that a residual hand, Candace, or did you have another question?
Sorry about that.
All right. Any more questions, comments, or do we want to look at the recommendations? I don't want to rush things. We still have, close to an hour on the schedule for this, but I also don't want to belabor the point if we would like to move the discussion forward. Go ahead, John.
Thanks. Yeah. I think maybe my brain's moving slowly because it's a Friday afternoon here, but I'm struggling just a little bit with the concept of the spawner reduction rate for a single year versus the spawner reduction rate for, I guess, the life of the brood or whatever. But so if fisheries were closed just in 1 year versus all prior years, that affected the escapement in the given calendar year. I'm just trying to, I know it makes intuitive sense that the spawner reduction rate that accounts for fishing impacts across prior years as well would be higher. But when I'm used to thinking about exploitation rates in either like a brood year exploitation rate or a calendar year exploitation rate sense. I see Will just raise his hand. Maybe I'll just finish real quick. For a brood year exploitation rate, you're summing the impacts for each age with the escapement for each age across multiple calendar years versus calendar year. You're summing the impacts across different broods with the escapement for a single calendar year. But with the spawner reduction rate that includes previous year impacts as well, your what is your your denominator? You're looking at the escapement in a given year, right? So that's across multiple broods. I'm just wondering, is there like a way that impacts are getting double counted some way if you're looking at multiple years worth of these spawner reduction rates that incorporate prior years? I'm just, maybe my mind's not quite wrapping around that right, but I don't know if that's a well formulated question or not, but maybe Will has a comment.
Yeah, and I don't want to cut off Emily, but I mean, this does remind me sort of, John, of why we were
Yeah,
kind
I
of
know.
having a hard time understanding each other about, the calendar year exploitation rate calculations in the CTC model.
Yeah.
And so I don't think there's double counting. And I think, we, and by we, I sort of mean the people who tend to do cohort reconstructions for California stocks versus the people who tend to use the CTC models, I think are just very used to different vocabularies and different units.
Mm-hmm.
And so, I mean, so the sort of SRR with the Y subscript, which, as I understand it, is essentially equivalent to what we're currently calling an exploitation rate for the Klamath tall Chinook. That is really not equivalent to either a calendar year exploitation rate or to a brood year exploitation rate, because it literally is only looking at the effects of fishing this year on this year's escapement. So there's like no adult equivalent accounting for, impacts on fish who would have come back in a different year. And that, I think, is very much consistent with what we're trying to get out of the control rule, where we want to say, how much fishing should we allow this year to get a particular escapement? And then conversely, the spawner reduction rate without the subscript can either be done on a brood year basis, in which case I think it is equivalent to a brood year exploitation rate, or it can be sort of indexed to a return year. And then if it is indexed to a return year, it's actually, I mean, it's going to be different from either a brood year exploitation rate or a calendar year exploitation rate. And it's essentially just going to show, in terms of this year's escapement, how much higher could it have been had you never fished on that cohort? So the denominator is just going to be, what could escapement have been this year if you add back all the fish that fishing has taken out of the population? And so again, I don't think that's the same as the denominator in either of the brood year or calendar year exploitation rate calculations the CTC does. And I'm probably not being very helpful, but just I think, yeah, there is sort of this fundamental mismatch in that, like, in CTC land, there are two kinds of exploitation rates. In California land, there are two kinds of spawner reduction rates. And their differences partially reflect the same sort of concepts, but they don't map one-to-one onto each other sort of in any circumstance. But I think depending on your exact purpose, I think there's potentially a use for each one.
Yeah, nothing like making it confusing for everyone, right? I agree. I appreciate that, and I'm not saying you're making it confusing. I'm saying we all make it confusing by having all these different terms and different ways of looking at things. One of the other things that we in CTC land look at also is what we call a mature run equivalent exploitation rate, and I think maybe that's more similar to these spawner reduction rates that you're looking at, where I think it's kind of trying to answer the question of how many fish would have escaped this year if there hadn't been any fishing in the past. And I think those are maybe similar. So I think I just need to spend a little more time trying to rationalize all that in my head and maybe work out a few examples in a spreadsheet or something like that. But I appreciate that. Thanks, Will.
Yeah, thanks, John. It looks like Galen put in the chat, that's what she was thinking too, with the, what is it, mature year exploitation rate?
Yeah, mature run equivalent. Yeah.
Mature run, yep.
What's interesting is that I guess if fisheries are maybe somewhat consistent over time, all these things should be, I think, fairly similar, but I don't know.
Yeah, well, that's where the thing that only considers fishing in the current year as it affects the current escapement, that's going to be lower than all the others.
Yeah, right.
But yeah, I agree that like in a stable sort of equilibrium situation, I think the rest would all tend to converge.
Mm-hmm.
But I'm not positive of that.
I think they would vary, but they would trend the same, and yeah, they would generally, on average, be similar.
Go ahead, Candace.
Thank you. Yes, I'm trying to keep up with John and Will's conversation and also solidifying it into my brain. So, is this generally proposing to calculate the spawner reduction rate in two ways based on whether or not you're looking at this retrospectively or for fisheries planning? Like from a fisheries planning perspective, I'm like, well, I don't really want to know the spawner reduction rate for what could have been. Had there not been any fisheries in previous years, what could the exploitation rate be? It's like I want to know the spawner reduction rate, of what this current year's fishing season could produce. So is what's being proposed to calculate it two different ways based on your scenario, based on whether or not you're evaluating from the cohort reconstruction or using it in pre-season planning?
Yeah, and I mean, it would be great to hear from Mike and also, Emily, although we sort of told Emily, like, she doesn't need to worry about some of the management weeds, but definitely Emily, if you want to speak up, feel free. But yeah, I mean, it kind of seems to me like I fully agree that, if you're saying I want to plan fisheries this year and say I want to achieve an escapement of, SMSY, then yeah, it doesn't really matter what fishery, I mean, it matters what fisheries have been in the past insofar as it affects your forecast, but your forecast, if it's based on jack returns or it's based on, returns of younger fish the previous year, the effects of previous fishing should already be reflected in your forecast. Right. And yeah, you just want to know how much can I forecast or how much can I harvest of what's left and still get the escapement I want. But then if you're asking the question, retrospectively, did overfishing occur? Then it seems like you shouldn't compare just the effects of this year's fishing. I mean, in some, completely extreme scenario, you can kind of make up a situation where, if you fished really hard last year, that may have, impacted the H2s and it would have meant fewer H4s, going to be able to come around this year. And so you may be in a situation where you're not going to be able to achieve your escapement objective, not as a result of the current year's fishing, but it's a fact that like, it's almost like a credit card fishery, or just sort of a different. So, credit card fishery right now, we use that term to refer to, the sort of management year cycles over September 1st. Mm-hmm. So, fishing that occurred last year after September counts against this year's management, availability. And, it seems like maybe we should be thinking about, the effects of fishing on younger fish the same way as that. So yeah, my thought is, and just thinking about, since I've been spending all this time looking at how FMSY values are estimated, like those are based on reduction in a cohort, not just the reduction in the most recent year. So yeah, it does sort of, at least in my mind, make sense to calculate it two different ways. I realize that complicates things, but the overfishing status determination, that's sort of a later separate step. So maybe at least it is two distinct calculations, but it's only kind of one at a time, maybe.
Okay. But it wouldn't be double counting. Because you have in your prior years, you have the resulting mortality that had incurred on your specific broods, but then also calculating, I guess, in the current year, the extra mortality that could have happened had you not had fisheries. I don't know. It's likely because I'm not fully understanding it, but it does seem like you could potentially double count, what mortality that had happened versus what could have happened from your retrospective kind of analysis.
Yeah, I mean, I think my take would be, I would say, I don't think there's a risk of double counting. My perspective would be that actually our status quo is undercounting with respect to overfishing. I think it's done properly with respect to picking the exploitation rate we want this year. But in terms of assessing whether overfishing occurred, I think we are actually undercounting currently.
Okay, thank you.
Do you have another question, Candace, or I'm assuming that's residual?
Sorry, I'm not doing a very good job at that.
Oh, no worries. This platform gets everyone. Go ahead, Ollie.
Yeah, so I have a nomenclature suggestion. Perhaps we should not call them SRR and SRR sub Y. We might find a catchier name for one versus the other so that they are easier to distinguish and keep track of in people's brains. So that's part one. I had another question and now it might have escaped me. So I might just stop there. Yeah, I'll stop there for now.
All right, thanks, Ollie. Any other hands, questions, thoughts? Otherwise, we can work through the recommendations. Go ahead, John.
Thanks. Yeah, I just had one, and this one might be kind of trivial, but wondering, I think you kind of explained it, but could you go back to the first slide with the main equation for the cohort reconstruction? Yeah, that one. Yeah. So I think when you were kind of explaining that the difference between annual about having the monthly time steps, when I was trying to think about this in my head, the A+1 would really only be an A+1 for when the month is August, right? So I think for every other month it would just be the number at the age for the next month up. Is that right? Am I thinking about that right?
So you're saying in other months it would just be the same, only in August it would
Well,
the time
yeah.
step.
So, I think if you're thinking about progressing forward in time, that the age, it would always be the same age, and then the next month until you got to, I guess, August, right? And then it would become the next. Is that right?
For just escapement, that would be 0, but the fisheries are happening throughout the summertime, so that's we do look at when the month of recovery was for ocean harvest, and then also natural mortality. We applied that every month, so regardless if there's no fishing and no escapement happening, there's still that small natural mortality rate that happens every month.
Yeah. Okay. I see.
Yeah, John, I think the thing just to jump in, sorry, but I think the indexing is all by month. So it'd be like month 1, month 2, month 3, month 12, month 13. So you could translate it into a year, but the A is going to be strictly in months. Is that right, Emily?
Yeah. Yeah, that's
so
a good.
Okay, so it's like age 1.1, 1.2, or I guess I'm just trying. Yeah. All right. I think it's probably trivial, but looks to me like you're taking the next age up plus a month based on that.
Okay. Yeah. It's yeah, you could think of it as on a monthly, so on a monthly scale. And
Yeah, if I could jump in, I think, yeah, John, I think, I mean, I definitely hear where you're coming from, and I think it's sort of a matter of notation and presentation. And I think, you can sort of at least the way I would think of this is sort of this equation right here is for an annual time step. And then, but each of these components are being calculated using a monthly time step within them before creating them to add together, basically. And that probably just confused things more. But I agree, you're right. The age in years is only changing between August and September.
Yeah. Okay. All right. Thanks.
All right. Come back to my standard refrain and threat. See if there's any more questions or comments for discussion. Otherwise, we can start working through the recommendations and see if we support them or if we want to recommend anything else. Looking for those little blue hands to fly out. Emily, if you can go to the, slide 33. Thank you. So yeah, our recommendations that were put forward here were to use the cohort reconstructions for postseason assessments, reparameterize the harvest model based on the cohort reconstruction instead of the SI, explore possibility of age-specific forecast models, such as for Klamath River, and use output for studies to better derive MSY and conservation objectives. Are these all recommendations we can support? Anything we would like to see kind of changed on this, or any, kind of concerns these raise? Or if we're all happy, then things are very simple. Go ahead, Jason.
I think I might be changing, so you might want to mute me. But I guess going back to the cohort reconstruction, that would be where I first go is, do we recommend this cohort reconstruction as a better methodology to move forward? And along with that, what do we do, assuming that we do recommend that, what then do we do about that north of Falcon component? So I'm not sure if one of those should be taken up before the other one, but I'm curious about that north of Falcon component and how that gets dealt with, or not.
Okay, yeah, thanks, Jason. Go ahead, Will.
Yeah, just on the north of Falcon component, I mean, I agree that that's an important thing to think about going forward. Right now, so we've done the cohort reconstruction both with and without considering north of Falcon impacts. Right now, the SI is done not considering north of Falcon harvest. There's really nothing fundamental to the SI that says we have to do it that way. So I think it's a very useful question to ask. Should we think about harvest north of Cape Falcon or not? But I think it is. I mean, I think that's a question we have to answer whether or not we move from the SI to the cohort reconstruction. Because again, the SI there are certain things that a cohort reconstruction can do that the SI can't do, but accounting for north of Falcon harvest is not one of those things. If we wanted to, we could just add north of Falcon harvest to the SI.
Thanks for that, Will. Go ahead, Mike.
Yeah, just to be clear, in the Klamath Ocean Harvest Model and the Sacramento Harvest Model, we are not taking into account north of Falcon impacts. And that's the way those models have been for sure. It's always been that way for the SHM, Sacramento Harvest Model. And I believe it's always been that way for the Klamath, but I haven't been around for the lifetime of that model. We did, with regards to the Sacramento Index, when we wrote the report describing it, we did assess what the north of Falcon impacts were at the time, and we judged them to be relatively small, and thus they weren't included, in what we were doing when the exploitation rates and so forth. And so, yeah, I mean, I don't know the exact reason why this has happened. I'm assuming that it has to do more with a management issue than an assessment issue. But I just wanted to, just so everyone knows kind of the way that this has been treated in the past and why this recommendation is slightly different.
Thanks for that, Mike. Go ahead, Candace.
Yeah, so just as a point of clarification, so I mean that north of Falcon harvest that was reported in this paper, I mean, on average, harvest about 5%, but the range of 2 to 13%. I mean, that's not nothing. But Mike, to your comments, it was looked at previously and decided to be not included because it was, some considered to be negligible. But I missed this point. If it was reported on, is it brought up here because it's shown to be increasing? Or like, is our harvest and impact rates from north of Falcon fisheries on this dock like increasing compared to when this decision was made previously that it was probably negligible?
All right, let's go John Kerry, then Will.
I don't know if maybe Will had a response there. I don't want to disrupt the train of thought there.
Yeah, thanks, John. And so, yeah, just briefly, I'm not sure about increasing, although certainly actually, if you look at the SI report that Mike was referring to, there had been an increase towards sort of the tail end of the SI data set. But again, I mean, we sort of bring it up, well, partly we bring it up because, when Emily first did the cohort reconstruction, quite reasonably in my mind, she just included all the ocean harvest. And then we were realizing, oh, wait, well, if we want an apples to apples comparison with the SI, we should take out the north of Falcon harvest, just, to make it an even comparison. But in terms of if we want to have a scientifically accurate estimate, in my mind, it makes no sense to just ignore some of the harvest. I think, there is potentially a question of implementation of like, if we start tracking north of Falcon harvest in the postseason, what do we do about our preseason models that aren't set up to accommodate that? And I think there's multiple ways to deal with it. One is you just have a mismatch between the preseason and postseason. I mean, right now we use forecasts that are never 100% accurate. We just do the best we can with them. But also, I mean, we have this system set up we know how to deal with the sort of credit card aspect of fisheries. And so, if we just say, well, on average, the north of Falcon fisheries contribute 2% of the exploitation rate, and not 2% of the exploitation rate, but they contribute additively 2% to the exploitation rate, then just do your preseason modeling like 2% in the whole. But again, I mean, I think this is sort of an important question. I think if it's a scientific question, I really don't see any reason we would say anything other than include north of Falcon harvest. But I don't want to distract too much from, the real, I think, purpose of this review is comparing the cohort reconstruction to the SI. And again, there's nothing that says the SI can't include north of Falcon. There's nothing that says the cohort reconstruction has to include north of Falcon.
Got it. Yeah. Thank you for clarifying that. So, yeah, I'm trying to keep it within, like the the intention of today's meeting is to provide, what is scientifically most accurate, assessment of exploitation harvest and everything. But and while it's not, I don't think our place in this meeting today to decide whether or not we should or shouldn't, I think it would be reasonable to, advise in our statements what this change would mean. And so if we are, going to account for this, then like you said, well, there's ways to incorporate it into the harvest model. So having some kind of like set aside or something off the top. So, but you should be accounting for it in your pre-season planning potentially. And if you're doing so for Sacramento fall Chinook, then maybe you should be considering the same impacts for the Klamath cohort reconstruction and the Klamath harvest model. And if south of Falcon fisheries are planning for impacts to Sac fall, north of Falcon should then vice versa. North of Falcon be planning for their fisheries impacts to Sacramento, and what would that mean? So while we're not here to answer those questions or debate those things, it might be worthwhile to flag those things for council. Like if we decide to make this change, it could mean X, Y, Z. Other questions need to be answered. And I'll stop there.
Yeah, thanks, Candace. Go ahead, Emily.
Yeah, I'll just also quickly just add to Candace's question about the fisheries north of Falcon and the amount of impact. I'm not in whether there's been a change. I'm not sure if I need to look again if the absolute impact has changed over time, but you could think of if there's less fisheries, like if the fisheries is closed off of California, that's going to lead to a higher proportion of impact happening north of California, and so that's I guess in the cases where there's less fishing happening in the state, that would lead to the proportion of harvest happening north to be greater north of Falcon.
Thanks, Emily. Yeah, that's definitely a worthwhile flag to note. Thank you.
All right, thank you. Yeah, so I guess splitting out that first recommendation, initially, do we feel the cohort reconstruction is an improvement on the Sacramento Index? And would we recommend using it moving forward? Thumbs up, thumbs down. Boos in the chat. Oh, go ahead, John.
Yeah, thanks. I mean, certainly to me, it seems like it's an improvement. It's accounting for a whole bunch of stuff that the SI doesn't. I think, at least in my mind, that's the case. I guess just kind of wondering, could you maybe Emily or someone refresh my memory on what you mean by potential time lag under the first bullet there?
Yeah, I meant kind of two different things. There's I guess would need to discuss what type of figure out what data needs to be included in the postseason assessment, and whether currently the speed in which that data is collected from the previous years are available. So that's kind of like a practical logistical potential time lag. And then the other time lag is more so biologically with the cohort reconstructions and needing, or just to have like, a perfect complete cohort reconstruction would not be possible given that some cohorts are not complete in the current year. But that's again an issue that's present in a lot of other cohort reconstructions that are currently in place now. And there's solutions such as averaging the past maturation rates to estimate the current cohorts, the incomplete cohort data and such. And so that's what I mean, both logistically and biologically.
Gotcha. Appreciate that. Thanks.
And did you have oh, there we go. Go ahead, Candace.
Yeah, just to answer the general question, yes, I think that the cohort reconstruction is an improvement over the SI. I think accounting for natural mortality, fishing-related mortality, maturation, and your estimates of ocean abundance is a huge improvement over the SI. And accounting for those similar metrics to your potential escapement, absent fishing, and even just generally having two different estimates for your ocean abundance and also for your potential escapement absent fishing. Yeah, I think this cohort reconstruction is an improvement over that. In terms of implementation, I think a lot more thought needs to be given in terms of when we recommend it for use and how we recommend it for use now versus, in the near future. Because there's a lot of different moving parts in terms of, the SAC fall work groups efforts towards developing new reference points. And so how to implement it and when, and, all of the parts that are potentially recommended in this paper, more thought is needed on sort of the implementation side of things, I think.
Perfect, and very well said. So it looks like we have agreement that on the cohort reconstruction, with some future work to implement it. For including north of Cape Falcon impacts, do we want to make a recommendation there? And that could be a broad one of it should be included with both the SI or the cohort reconstruction. Go ahead, Oli.
Yeah, I'm gonna just sort of as the note taker, Tommy. Can we just sort of take a pause and get folks to articulate their favorite things that this is adding? I'm sort of trying to make sure I have a list of the various things that this cohort reconstruction is we feel like doing better than the previous work. And my scattershot list at the moment is sort of these non-harvest effects, so drop off mortality, impacts on not mature fish, some of the changing assumptions about harvest in California being assigned to not all of it being assigned to Sacramento, some of these time varying maturation rates, some things about what else was there? Yeah, ability to track natural and hatchery separately. Thank you, Will. Write that down. Anything else? And early marine survival. Thanks, John. The other thing I wanted to say is that I think, sort of as an aside there, but this doesn't happen unless California really radically upped their game and doing a bunch of stuff in the rivers about 10 years ago, and they changed their marking. And so I think that is something worth, shouting out and commenting on in the statement as well. So I would say, please feel free to chime in if I missed something big there in terms of major points. So shout at me if I missed something, but those are my ones that I had sort of scratched down at the moment.
Great. Thanks, Oli. Yeah. And does anyone have anything else you want to add to Oli? Either, speak up or put it in the chat. Candace, is your hand still up or is that a new hand?
Yeah. Something else to add to Oli's statement. Thanks for, the point on recognition on how far the department's come with our sampling and to get this to where we are today, but we do still have a long way to go in order to be able to implement this in a more real-time basis, both for a cohort reconstruction and for, down the road, age-based abundance forecasting. For example, we're working on receiving data, sample data and scales from some 2022 runs. So that just kind of gives you an estimate of, the lag time for, receiving this data from all of our inland partners to do the reading and everything. So we've come a long way, but there's still a long way to go in terms of, more real-time implementation.
Great, thank you. All right, well, if anyone else has more thoughts for Oli, feel free to interrupt or put them in the chat. Do we have agreement on including impacts north of Falcon for both the Sacramento Index and for the cohort reconstruction? Based on discussion, seemed like there was fairly broad support for that. Again, there'd probably be some implementation challenges, but. And is that a fresh hand, Candace, or?
Sorry again.
Oh, no worries. Just didn't want to talk past you. Go ahead, Galen.
Yeah, I mean, I can definitely see why there might be implementation or policy reasons not to, but in terms of scientific reasons, I feel like they should be included, or at least that option should be there. it gives a better understanding of what is happening with the stock.
Great, thank you. Go ahead, John.
Yeah, just going to second that. Kind of going back to what Candace said about the cohort reconstruction in general. I mean, I think scientifically, biologically, there's probably not a reason to exclude the Cape Falcon stuff, but it is really important to make sure that we think about implementation and implications this would have for that. So.
Yeah, great, thank you. All right. And then for the other three recommendations, the reparameterizing the harvest model, exploring age-specific forecast models, and using outputs to better derive SMSY. Do we want to just kind of broadly support those? Are those things that would come in the future? Because I don't think you can really do that without the cohort reconstruction being done. Go ahead, John.
Sorry. Yeah. Really quick, going back to the North of Falcon thing, there's one other thing to mention that would be worth thinking about too, is the availability of data there as well. Candace was just mentioning that it's not easy to get everything ready in time based on the age and all that, but I'm not sure what the general schedule is for colored wire tag reporting into ARMIS anyways for some of the ocean tag recoveries there. They may or may not be available by the probably January-ish timeframe that they'd be needed for. And on the last three things there, I guess kind of question about timeline. It seems like they're maybe moving getting further out as you go down the list there. But what would the kind of amount of work needed and realistic time frame be on, say, reparameterizing the harvest model? And I don't know who this is the best question for, but is there any issue between having a mismatch if you start using the cohort reconstruction for postseason assessments, but don't have the SHM set up to accommodate that yet, and so you have like a pre-post mismatch? Is that anything to be concerned with?
Thanks for that, John. Good point. Go ahead, Will.
Yeah, thanks. And I'm definitely not the right one to answer on the sort of timeline of reparameterizing the harvest model. But I initially raised my hand with respect to the sort of timeline question about, when would the North of Falcon tag recoveries be available? But then this maybe also factors into this mismatch question. And so in my mind, certainly the sooner those data are available, the better. But I'm thinking about if if the way we handle it in the preseason is just, a sort of average kind of deduction off the top, like we were talking about, then maybe it doesn't matter how timely those data come in. And then I think if we just want the most scientifically supportable postseason status determination, if we have to wait another year to do that, I think that's been deemed, that is the way we do things for a lot of the northern stocks that use the CTC model. We tend to report exploitation rates for the year that just happened for the California stocks, whereas for the northern stocks, there tends to be a time lag there. And I think, for retrospective status determination, maybe that time lag is not really a big deal. Let's see. So in terms of, is it an issue then if we say use the old tools in the preseason planning process and the new tools for postseason assessment? I can see arguments for why it would be ideal if they were as consistent with each other as possible. But given that already we have this time lag in status determination for some of the northern stocks, it seems like doing the status determination as well as we can should be our priority. But obviously, I'm recused, so I'm not actually recommending here. I'm just offering some thoughts.
Thanks, Will. And go ahead, Mike.
Yeah, just circling back to John's question about feasibility timelines and that sort of thing. It's hard to say. You know, I mean, we do have models. You know, we have kind of templates for doing age structured, you know, harvest models and so forth. And so that, you know, there's, in theory, that shouldn't take a huge amount of time, and it wouldn't be that different likely than the Klamath Ocean harvest model. And then, you know, just being able to update the postseason estimates, that would be a really, I think, good thing. And we'd have to have more discussions about how that would be done. You know, there are issues associated with having, and you know, I don't really want to get into workload situation, but something to be mindful of is, you know, the current number of harvest models that we use right now in the preseason process has basically got us like pedal to the metal right up until the March council meeting. And so there's going to be, you know, an additional, you know, workload associated with this, and that, you know, I'm confident that we can get through that, but it's just something to be, you know, understood, I guess. But you know, we're not going to make that an excuse, but I think there is going to be a lot, or there's going to be a number of things that have to be put in place before all this could really become operational. We probably need more people also. Anyway, that's I don't know if that's straight beyond what you guys are looking for, but just trying to give, you know, a realistic appraisal of what could be done here.
Great. Thanks for that, Mike. And yeah, I'm not fully certain what our like kind of boundaries are for where we're commenting, if we're just sticking to kind of scientific and technical merit, or if we want to comment on some of the workload challenges and things of that sort. But definitely some concerns to keep in mind. Yeah, I guess looking for any other hands or thoughts or concerns. And don't be shy if you're having trouble raising your hand.
I guess just to tack on to what Mike was saying, like, I think it's become clear over the past couple of years that the STT's workload is not ever going to get smaller. And probably is just going to keep expanding. And there are discussions of council efficiencies and COPs coming up in November and next year. So, you know, thinking about how this fits into that, like, if the things are becoming more high priority, then there also has to be an increase in capacity, like, and the humans that are on the STT right now can't just be doing more overtime. Like, there needs to be help for them.
Yeah, thanks for that, Galen. Go ahead, John.
Yeah, thanks. And thanks for that, Galen. Certainly wouldn't disagree there. I think it goes beyond that too, though, right? And I mean, this is going to be require much more data processing in a, you know, making sure it's available in a timely manner, if I'm understanding things right. So it goes beyond just the STT into, you know, the capabilities of the management entities to get all the information together on time too. So I mean, the STT can only do some of the things that need to be done once the other data is available, and if that's not there, then we can't do it, right? So
Yeah, we just don't get to comment on how other entities spend their money, their time.
no, I agree. Yeah, but it's an important point that there are data needs here that would need to be met, right?
Go ahead, Alex, then Will.
Hi, thanks. I just wanted to kind of go on record as saying I appreciate the conversation that's happened all day today, especially on this topic regarding implementing the North of Cape Falcon impacts. And that I just concur with everything that's been said. I do think that this is an improvement and that it makes sense to include North of Cape Falcon impacts, but that has to come with the grander context around feasibility, both in terms of the technical, but also managerial and policy side. But I do agree that technically it makes sense to include those impacts. So, thank you.
Great, thanks, Alex. Go ahead, Will.
Yeah, thanks. And I want to just build on a couple of the things John Kerry said with respect to timeline, and then also, obviously the sort of dependence on data streams that the council itself is not producing. And so, yeah, absolutely agree with those concerns. I think a couple things that might be worth emphasizing are that there are sort of different uses of the cohort reconstruction, some of which you really do need the most recent data for, some of which maybe it's okay to have a time lag, and or maybe even there are some things where it's useful to do a cohort reconstruction every so often to get sort of a better sense of the productivity of the stock, get a sense of, if you are still using something like the SI, get a sense of whether it's error or whether it's sort of diversion from the cohort reconstruction has been changing over time in any kind of way that would make sense. And this is probably, well, this is a very inexact analogy, but I'm wondering if there's sort of any analogy to the sort of base period update approach with FRAM, where, every however often there's this major effort to, improve and bring up to date our understanding of the system. And then, but that sort of, there's a massive workload associated with that, but then that massive workload is not repeated every single year. It's more of a kind of periodic check-in. So while I would prefer, or, think there's strong advantage to doing the cohort reconstruction every year, maybe there is value in a system like that if that's all we can actually accomplish. And then another sort of compromise or, way of using at least components of the cohort reconstruction, we talked about, and I think there's a real advantage to doing the cohort reconstruction for both the hatchery and the natural origin component. For Sacramento winter Chinook, we currently do the cohort reconstruction only for the hatchery component. There's still a lot of data needs there, but it does at least alleviate the need for the scale aging data on a timely matter. And so there may be things we can learn looking at just a hatchery only cohort reconstruction from year to year. That still might be a better indicator of exploitation rates than the SI. If we sort of assume that maturation rates are similar between hatchery and natural fish, maybe it's giving us a better ocean abundance, et cetera, also. So, maybe if the best we can do is a hatchery cohort reconstruction every year, that still might be better than the SI.
Great, thanks for that, Will. Go ahead, Candace.
Yeah, a question, I guess, for the larger group here is just thinking about, well, the timing of everything and where we could be, where we need to be, and also with regards to the cohort reconstruction and the age-specific forecast. Are there other areas that are doing age-specific forecast, cohort reconstruction with like a 1 year time lag? Like if we can't get all of the, all of the scale data and inland hardwire tag data ready from that fall to, February 1. But if we had it for the prior year, could we still be doing cohort reconstruction and age-specific forecast even with that 1 year time lag? And my thought there is like, well, maybe that's, more near term, something that we could achieve. And so if it's feasible, maybe it's like a baby step before we get to where we really need to be.
Yeah. Go ahead, Will.
Yeah, and partly I just wanted to draw people's attention to the chat. Apparently, Mike O'Farrell is having some network issues. which is unfortunate because I think he would probably have a lot to add right here. And so I can't really speak to where else age-specific forecasts are being used, although I suspect there are other places. But I was thinking about, what are things we could do in terms of forecasting, even if there was more of a time lag. And, one thing that I had noticed looking at the Klamath forecast, that is based on, age-specific regressions. I mean, the coefficients of those regressions don't really change much from year to year. So at least on the sort of side of fitting the model parameters, that get applied to your escapement at age from the previous year, it doesn't seem like a time lag is something that would block you from doing a more age-structured forecast. But then I was also thinking about, okay, so what if, though, we still want to have those age-specific escapements from last year to go into a fully age-structured forecast, but what if we didn't have fully age-structured escapement from last year, but we did still have what we have now, which is sort of a preliminary sort of breaking of the total escapement into jacks versus adults? And what if we used jacks in something like an SI-based forecast, or sort of like the current SI forecast, where it's jacks predicting potential escapement in the absence of fishing, but then we actually would have potential escapement in the absence of fishing as the data that goes into informing that model, rather than right now we're saying the SI is the potential escapement in the absence of fishing. And so maybe we could still have a jack-based forecast, but one that was tuned to escapement in the absence of fishing rather than tuned to the SI, and that itself might be an improvement. And that one, again, would not necessarily need totally up-to-date cohort reconstructions. You need enough to have a bunch of potential escapements in the absence of fishing to parameterize the model, but then as your annual input, all you really need is jacks versus adults. And we're already coming up with that in a sort of approximate way already.
Those are really, really interesting and intriguing thoughts. So thank you.
All right. Any other thoughts, questions, concerns? Otherwise, I'll check in with Ole and see if there's anything he needs. Go ahead, Jason.
Yeah, I was very slow on the draw with that one. This is responding to Will. Yeah, in most of Puget Sound, we're simply producing an age-structured terminal forecast and then using FRAM to back that terminal forecast, terminal abundance, out to a full cohort. And we're using a recent year average for that. So it's certainly a mix of the two approaches, and it's not exactly what you described, but it's also not a fully age-structured annual cohort that's being used to produce all of our abundances. So there's definitely precedent for some of the analyses you described.
Great, thanks, Jason.
All right. Any other hands, thoughts, questions? Otherwise, I'll check in with Ole and see how he's doing on the note-taking front.
Yeah, thanks, Tommy. I think I'm doing pretty good. I got lots of notes. I guess my main question is I'm just hearing a lot of sort of concerns about how this is all going to work out, right? So how is this going to get translated from what Emily has done to what it shows up in the council process? And there's been a bunch of sort of proposals about simplifications and, choose part A and part B, but not part C, and, multiply them together, and, like some complicated ways of how this gets implemented. I didn't hear anything that said we need to do it this way. So I think we're just going to I'll probably just leave it as something more broad structure that sort of says, this is going to take a little while to figure out how this gets implemented in practice. If somebody has something really specific they want to add in there, I would love to hear it. But it just feels like there's a lot of flux about what parts get picked up and run with, and what parts get be not quite as important. So if somebody disagrees with that, please let me know. But otherwise, I think I'm okay.
Thanks, Ole, and I think that's a good approach, especially since our task was mainly to say if the cohort reconstruction was, a good approach or not. Everything else can get sorted out with time. All right. Not seeing any other hands, I will pass it back to Galen, and I guess we're on to public comment.
Actually, I might have one more thing that I'm just sort of make sure I say this before we run away. Is I will probably say that we like this cohort reconstruction. It's not set in stone. I think like this isn't the only way and the only things you could include in the cohort reconstruction. So I will put a statement in there saying this is like one of those things that can always be better. So it's totally good for use now. It's not a fixed thing that will never change. So I just want to make sure I articulated that before we go back to Galen. So
great.
I see John has his hand up too. Yeah.
Yeah, thanks. I don't know if it's a worthy point or not, and then maybe somebody already mentioned it. But I think the general structure of this cohort reconstruction is not anything new, right? It's kind of very similar to the way the Klamath Fall cohort reconstruction is done. So kind of just like it's not a novel concept here, and I don't know if that. I mean, and others have already been reviewed, so I don't know if that's an important point, but. More than that, I just wanted to thank Emily for the presentation too. Make sure we did that. It was a very nice presentation. So thanks.
Yes, definitely. I'll echo that. Thank you, Emily. And with that, I'll pass it back to Galen.
Yeah, and I'm actually Mike is supposed to be in charge of public comment, but if I guess that depends on whether he can hear us and speak or not.
I think my problems have been solved over here. Miraculously.
Okay.
Yeah. Thank you for your patience, though.
Then it's all you.
Okay, thanks. Yes, we've come up against the second public comment period in our meeting here. I will open it up right now for anyone who'd like to make a public comment. I see one hand up. Brian McLaughlin, please go ahead.
Thank you. Can you hear me all right?
Yes, I can.
Great. I want to thank you again, everybody at the meeting, for the discussion. I found it, very informative, very interesting. I want to circle back and provide a comment with respect to the discussion you had earlier on the derivation of MSY and SMSY. I just want to urge you all, each group, in your reports to the council, to, if you could thoroughly explain and emphasize the challenges of calculating FMSY and SMSY with regard to the Sacramento River Fall Chinook stock, given the stock's high PHOS, percentage or proportion of hatchery origin spawners in the natural areas. My working assumption is that the PHOS is somewhere around 60 to 70% overall. At least that's some of the things I've looked at. I'm sure others could come up with a better figure, but it's higher in some areas, some years. But whatever it is, it's very substantial. And I think it's very important for the council, for stakeholders, for the public to know what this MSY figure of the fishery MSY figure of 0.58 really represents and what it doesn't represent. Quite frankly, I'm still confused. I don't know you're trying to maximize and what you're trying to sustain. Is it the productive capacity of the composite stock as a whole? Is it the productive capacity of the natural origin component of the stock? Or is it the productive capacity of natural areas with a composite hatchery origin and natural origin production? And why is this the yield that you've chosen to apply the MSY figure to? And I'm particularly, as a stakeholder that has participated in the season development process, I mean, we live and die by the numbers that the scientists, especially the salmon technical team, come up with. And so it's so very important to understand, what they're trying to represent. And also the uncertainties the assumptions and the policy and judgment calls that went into developing, this number, because it will provide a cap on, fishing rates that are allowed. And of course, that affects people's livelihood and all things like that. And I'll be very frank with you. It seems like you came up with a number because you needed to come up with a number. And I don't really have a lot of confidence that it reflects the true population dynamics of the Sacramento Fall Chinook stock, or even the natural area component of the stock. So I would just urge you to be very thorough in explaining that, so that the council can, to the extent they take the time to go through this, can really understand what this number represents and how it was developed, and how it might be used. Because it's important to remember, at least for me, that this number is just a starting point for development of conservation and management measures. So I think understanding it, have the policymakers understand it, is going to be real important when we move on to that next point where policy becomes even more important. Anyway, I do want to thank you again for hearing my comments and responding to them. It was a very informative for me to listen to it. Thank you.
Thank you for the comments. Any other comments from the crowd? Not seeing any hands raised. Feel free to jump in if you would like to make a comment. Not seeing and hearing none, I think we can end public comment and move on with our agenda.
Thank you, Brian, very much. And thanks, Mike. And one more huge thank you to Dr. Chen for her labors and presentation here, and putting up with questions that really ran it. I know it's not an easy arena to step into, and you did a great job. And it is really nice to see uncertainty being incorporated into these cohort reconstructions. It's something that SSC has been asking for a long time, and for you to come in and do that has been great. And thank you to Will too, although he's used to our arena, so it's a little less magnificent of him to step in and do, but also appreciated. We are at the wrap-up portion, and the SSC Salmon Subcommittee report. Planning is first, but I think it's going to be pretty short. I need to write something, Oli needs to write something, and we need to get comments from the rest of the Salmon Subcommittee before the briefing book deadline. Angela or Robin or Marlene, do you know that deadline off the top of your head?
Hi, I'm sorry. Slow on the clicker there, but the briefing book deadline
out of nowhere.
is October 16th.
October 16th. Okay. So yeah, if Oli and I get the draft out to the Salmon Subcommittee by the middle of next week, that still gives some time for thorough comments and getting it back formatted and everything to Marlene or Angela for the briefing book deadline. Is there anyone for whom that doesn't work on the SSC? Okay, Oli and I will do our homework and then hopefully give you all a week. Is there anything else from SSC folks?
So, hey, Galen, just to confirm, so yeah. I'm sending you something on Wednesday. Is that what I'm doing? I like a firm deadline.
Yes, you will have something to me by Wednesday. I will have something written by Wednesday, and I will put them in the same format in the same document and send them out to folks either Wednesday afternoon or Thursday morning.
Okay, sounds great. Thanks.
Okay, thanks to the SCT and the SSC, and I think that closes our business. So I'll leave it to Mike for the STT wrap up and to adjourn when that's done.
Yeah, thanks, Galen. Yeah, it would be good to have a similar conversation right now with the STT as we just heard from the SSC. We know that the briefing deadline is October 16th. I'm going to just put out there, maybe we can try to put together a draft statement by Tuesday of next week. Would that work for people? And I guess I would also check in with council staff to make sure that I'm thinking about this correctly and, leaving enough time to, edit our report before we have to submit it. Thinking trying to get a first draft out by Tuesday. I'm not hearing any issues with that. So let's plan on that. John, you and I were sort of moderating the two items, the two main items in our agenda. Maybe we could work together to get that first draft in place. Would that work for you?
Well, I'm not sure how much moderating I did, but I am traveling in all-day meetings all of next week. Happy to try to help. My availability might just be somewhat limited.
Okay. Sounds good. And okay, how about this? I will put something together by Tuesday and pass it around for the group. And
This is Robin. Maybe Candace can help on the second half if John is busy.
Send a message to Mike saying, Mike, you can tap me in for helping you out with some of the support.
okay, well, you got volunteered and then you volunteered yourself, so that's great. We'll take that. Yeah, let's. How about I'll take the proxy SMSY-MSP ratio part, and you take a stab at the SAC-FAL cohort?
Yeah.
And is that all right?
Yeah.
Okay, great.
Thanks, Candace.
We'll get you back, Sean.
I know.
In November.
Okay. Yeah, so let's just plan on that. I don't know if there's anything else that we need to discuss as a team relevant to methodology review. I think we'll just we'll get started with that draft on Tuesday and work on it from there. That's all I've got. So Galen, it looks like we're in the wrap-up stage here. We both talked to our respective entities and have a plan. Wondering if there's anything else that you would like to say, or anyone else before we adjourn our meeting.
No, just thanks to Will and Emily and to all the folks on both committees who participated. I know it's not fun to have meetings on Fridays, but we made it through.
Yeah, I echo that. I agree that methodology review is that's a heavy lift, especially for the people who do all the work ahead of time and get it in place in time for us to review it. So many thanks to everyone who participated today. It's much appreciated, and we'll likely see many of you in November, I believe. Okay, I guess I have to say meeting adjourned.
It's official now.
Thanks, all.
Thanks.
Thanks, everyone. Have a good weekend.